So let me formally welcome you to today's event, which is surveying small craft engine installations. Delighted to welcome Geoff Waddington. Those of you who don't know Geoff, well, I'll let him give a little potted history in a minute. But congratulations to Geoff. He is now the current president of the International Institute of Marine Surveying, a role that he took up following the AGM back in June. So it's nice to see you, Geoff. And I know you've already been beavering away on a number of projects below the line since you've taken up that role. I only want to give a very short introduction to you, and I thought the way to do that was when I looked at the modules that you have authored and you mark and you tutor as part of the professional qualifications, there's a bit of a clue. So let me just run through that. So surveying large vessel main engines, Unit 15. Unit 16, surveying large vessel auxiliary systems. Unit 23, inspecting yacht and small craft engines. Unit 24, surveying small craft systems and mechanical installations. And Unit 26, surveying steel and aluminium alloy craft. I think it's safe to say, Geoff, you know a bit about engines, and without further ado, I'm going to hand over to you.
Yeah, thanks, Mike. Yeah, no, well, that was where I started in my career 50 years ago, was with as an engineer. So yeah, my roots are with all things mechanical. But then I got wooed into the world of structures and stability and shipwrighting, and etc., etc. So I was fortunate to see quite a broad spectrum, really, of surveying disciplines, which has helped me a great deal over the years. So no, it's been good. I've enjoyed every minute of it, to be honest. It'd be sad to retire, but eventually I'll have to give it up. Getting too old now. But anyway, I shouldn't say that with Jeffrey Casciani Wood online. I think nobody's more senior than that in our profession at the moment. So yeah, nice to see you, Geoff. Yeah, during the presentation, Mike touched on this. I'm happy to have questions at any time, because at the end of the day, it has to be a bit interactive. It's difficult. It's one thing to stand in front of a room full of people, and it's entirely something else to sit in front of a screen. Although I've got a couple of little icons here and I can see some smiley faces, it's it's a surreal world, isn't it? I mean, and we're doing a lot of this these days. I mean, we have our board meetings online, we have staff meetings online, and then we've got all this tuition going on online. And I believe there are actually surveys going off online now, which is a bit of a worry to us all, but there you go. So yeah, so if you have any questions, please do ask questions, because that will help me. It'll spur me into my thought processes. I've made a lot of notes to go with all of this, but there will always be things that I'll miss that you might be able to bring up to my attention. So that would be good. I mean, it's an interactive sort of thing. So, and I think if you keep it that way, I'll give you an opportunity on occasions to ask questions, and I'll be sharing experiences. You can call them stories if you like. So there's lots of stories, and I got a million of them. But some of those which are relevant to what we're going to be talking about today, I've included. Obviously, no names, no petrol, but it's just really to highlight some of the things that happen and can happen, and some of the thought process that need to go in behind it all. So the whole idea of this is I'm not going to try and make you all engineers. That's not the the reason that we're doing this. It's more to find out whether you want to make the decision to include mechanical installations or not. I know in the past I've come across a lot of surveyors from other institutions who don't include engines or mechanical installations at all, and they only do structure, and they make it perfectly clear when they write their report that they will only cover the structural aspects of the craft, and everything else mechanical would fall to an engineer or a specialist in that particular discipline. and that's fine. However, personally, I feel that if you're surveying a motorboat and you don't include the mechanical installation, then it's hardly really worth turning up, is it? Because the most important thing about a motorboat is the mechanical installation. So I don't know how many of you do include or don't. What we're going to try and determine is what level of inspection we should be or could be undertaking. There are maybe some engineers amongst you, I don't know, we'll find out as we go along, hopefully. I know that there are engineering surveyors out there. I used to be associated with one, and he specialised purely on engines, to the extent that he did boroscope inspections, and actually did internal inspections of engines, opened them up and inspected them and did reports on them, which is a very specialist field. That's not where we're going today. I don't think that's within the remit of the average surveyor, small craft surveyor, although I'm sure there are people out there who could do it, and maybe even do it. But in undertaking a survey, what I'm saying is that you should give an opinion on the vessel, and that should include the mechanical installations and the drive. So at the end of the day, a surveyor is actually an observer. The definition of a surveyor is an observer. So what you've got to say is, what is it, where is it, and how is it? And I always preach that to my young surveyors, is I need to know what it is, where it is, and what it's like, basically. And you need to be able to describe it in a technical form, not just say, there was a so-and-so, and it looked okay. We need a little bit more information than that. So, but to a certain level. And the other most important thing, of course, is taking photographs. Now, I don't know, I know there are surveyors out there, and I've been involved in litigation involving other surveyors who didn't take photographs, and it is a failing. Whether you use photographs in your reports or not, it is incredibly important to take photographs, lots and lots of photographs, because that's your insurance, because that's saying what you saw on the day. When somebody comes back to you and say, well, you obviously missed this, and you say, well, actually I didn't, because I've got a photograph of it, and that has saved my skin many, many times. So even if you don't include photographs in your report, having photographs on file from the day is absolutely essential, in my opinion. So I might ask a question now to you guys. How many of you, it's difficult to have you all answer at once, but do the majority of you take photographs or not? No? Those say aye, raise your hand.
I take photographs.
I'll do about 200.
Yeah.
Absolutely. Yeah. Well, and quite wise too. I can think of, well, I'll give you some instances later on, but there have been many times, and only just recently, where people have come back and say, oh, my engineer, my knowledgeable engineer has just attended my vessel, and he says that this is wrong and you should have spotted it last year when they did the survey. And then I say, well, actually, that wasn't the case. Unfortunately, you will fall foul of that very often. The very knowledgeable engineer who turns up and says, oh, this is wrong and that's wrong, and is basically trying to generate work for himself at your expense. But anyway, we'll cover that later on. But it's interesting.
Just to interject, Geoff, sorry, it's Mike. Several people have popped up on chat. Yes, everyone takes lots of photos, is the simple answer.
Good. Yeah, yeah. And don't have a terribly expensive camera either, because they do end up in the bilge. And also a small camera can go to better places than a big camera can. So, but there are some fantastic bits of kit out there these days with incredible lenses, and yet they're all quite small, and they've got steadying devices, so you always get a good clear picture, and they're all very, very swept up. But it's not really very good to see a guy going around with his mobile phone, using it as a torch, and then using it as a camera, as a one-hit surveying tool. I think it's best to invest in a half-decent camera and leave your mobile phone on the table. So where do we start off with the first page then? What have we got here? So philosophy, as we've just been discussing, whether to include a machinery survey or not. This is also dependent upon the machinery that you're looking at. Even in the old days, it wasn't so bad because engines were very simple. But nowadays, they're getting more and more complicated. It's like when you lift the bonnet on your car, and basically, yes, there's an engine. But there's no wires, no pipes, nothing. It's just a lump. And to do anything to it, you need to plug a computer into it and download the history of the engine and what's gone wrong with it and what hasn't. And its service history and everything else is already there. And that's brilliant. But it brings with it a problem for the surveyor because you can't see any of that. So it's always advisable, if you've got a modern EDC, EVC or whatever engine that's fly-by-wire, is to recommend that the service history is downloaded so that you can see what's gone on with the engine. However, that also is a benefit because written service histories are very unreliable, and so it's good that these things are actually recorded. And as we'll see later on, we can use that to good effect when we find it, when we go into do like a damage survey or where something's gone horribly wrong and you need to determine what actually happened to the engine. Before you get into the survey itself, everyone does a little bit of research, I hope. So you'll find out where the boat is, where it's for sale, and download the sales details. These also can be of great assistance with performing the survey, but they can also lead you a bit astray because sales details are notoriously unreliable and quite often are wrong. So we have to take that with a little bit of a pinch of salt, but at least you know what's being said about the boat before you actually get there. And then, of course, you need all your equipment and everything else. So pre-survey inspections. Well, this depends really on the conditions on the day of the race. So very often you'll have one of two scenarios. Either the boat is afloat on its mooring and it will later be lifted into slings and washed off for the survey, hopefully, because if it's not washed off for the survey, that makes the whole survey incredibly difficult. And then on completion of the outer water survey, it gets relaunched for a sea trial, and then you get a chance to finish off the mooring of the survey back on her mooring. The other scenario, of course, is that the boat is already ashore and it's dry and clean, and then it's launched for sea trials, which makes waterline checks and things like that initially difficult, and so the things that you would have done with the boat afloat are then done in reverse when it's later launched back into the water. So as we'll see later on when we get to stern drives, a lot of things can be discovered just by looking at the boat. Even if it's afloat or even if it's in or out of the water, is it soot stained? How low is it floating in the water? What's the water line? I used to, when I was doing training, physical training with students with the IMS, we would go down onto the pontoons and walk down the pontoons, and I would point out, well, that's a good stern drive installation, that's a bad stern drive installation, that one's really worrying, just by how low the boat is sitting in the water and how much of the stern drive you can see. So if you can see the top of the stern drive, then, well, things aren't too bad. If you can't see the top of the stanchion shield, then you've certainly got a problem. So it's just little things like that before you even step on board. It's worth having a look. Is the boat floating level? And as I say, the soot staining. So if we take type 1, where the boat's afloat, you may have another issue to deal with, which would be the weather. So are you going to do the machinery first, or are you going to do the boat first? Well, if it's dry, I would crack on with the boat if I were you, because in the UK it's bound to rain. So let's get the outside of the boat done and then drop down into the engine room and do the other bit in the dry. Or maybe the other way around, depending on what the weather dictates. And also, as our good friend there said, he was just doing a survey in 40 degrees of temperature. Then it's always a good idea to do it while things are cool. So if you can get into the engine room and check out the engine before the engines are started, which is important to see the engines cold and then see them started, it also helps because the engine room temperature is then not 120 degrees and you're not soaking your paperwork with sweat. So it's good to get into the engine before anybody gets there to start it up. So when we get down into the engine, we need to determine we need to determine a lot of things. The first thing is the first impression. If you get into a machinery space, there's several things which you will notice, which you can't help because it's part of the natural function of things, is you'll think, can I smell anything? Does it smell of fuel? Does the engine room smell of smoke? Does it smell oily? Is it soot stained? Are the bilges clean? Does it have a bright, clean looking, is it a bright, clean looking engine room, or is it a dingy, dirty looking engine room? So you'll get an initial impression as to whether or not this engine compartment has been well looked after and what the maintenance has been like, because this is what's going to be the most important factor in your decision on the condition of the mechanical installation. It's your opinion of how much maintenance has been done. So the engine details themselves may not be legible. This is another problem. The engine plates do wear off and you can't read them properly. So then that means you've got to record as much of the engine details as you can, so that when you get back to the office later on, you can research to find out exactly what engine you were looking at. We have on occasions had problems where the engine was recorded as being a 500 horsepower on the sales blurb, and the person purchasing the boat thinks that he's got 1,000 horsepower of engine in his boat and he's really happy. And when you get down there and you find the model and you do the research, you find out actually it's not 500 horsepower at all. It's probably 435 or maybe even worse. So that's always worth doing. And sometimes you get into a bun fight then over, well, I don't think you've got the right engine. And so then you have to make sure that you've actually got the right information. So recording the engine details, the model, the serial numbers, if they're legible, is obviously one of the first things you need to be doing. Then start working your way through the engine itself. So you've got the oil. We're going to cover in oil again in greater detail later on, but initially, obviously, you pull the dipstick. What's the oil level like? I mean, is there any oil on the dipstick for a starter? Or is it over full? Some engines have problems with dipsticks, so you have to pull them out, clean them off, and put them back in again. Because Volvo engines have a habit of sucking the oil out of the dipstick tube. So when you first take it out, there's no oil in there at all. Well, once it's been out, put it back in again and have another go. You'll find that actually then the oil reappears. So that's the first thing. And have a piece of tissue paper handy, or filter paper if you're really professional. And then you put a blob of oil on the tissue paper or the filter paper, and that gives you an impression of how much carbon's going to be in the oil as the oil spreads across the surface of the paper, and it'll leave a ring behind to show how much carbon was actually in oil. How does the oil feel? Is it still viscous? Is it slippery? You know, going back to Geoffrey in my days, we even had a thing called a crackle test. I mean, I don't do this these days, and I don't think anybody else does, but what you used to do was have a lamp close by with a bulb on it, and you would smear oil over the bulb, and if it crackled, there was water in the oil. Geoffrey would probably laugh at that one, but that's going back a bit. But yeah, so you're not here to actually test the oil at this stage. It's just to give an opinion. So you're looking at it. Is it thick? Is it black? Is it heavy? Is it clean? Is it still viscous? And then you give an opinion. Does it smell of fuel as well is important, because you can have fuel dilution, which makes it look clean, but it also makes it thin, but you can also normally smell the fuel. And if you're brave enough, you can taste it. Okay, so next part of the system to check would be the engine coolant. All right, be a bit careful here. Some engines have header tanks, so when you pop the cap on the top of the engine, you get an influx of cooling all over the engine and into the bills, which sort of could make you a little bit unpopular. But to check the coolant, have a coolant tester with you that checks the strength of the mixture, but it also gives you an opportunity to see how clean it is. Okay.
Can I jump in? It's Mike. I've got a question for you from Paul, which I'm going to partially answer and then go over to you to answer. Paul says, would you recommend taking an oil sample? I know that James Wren, who's our regional director in America, small craft surveyor up in the Baltimore area, routinely takes oil samples, sends the way to a lab. He has a 24-hour turnaround and can then feed back the results to the vessel owner operator the following day. What's your view, Geoff, on that?
Well, we're going to get to oil samples a bit later on. So, although I'm obviously aware of the time, and I don't want to make this a whole afternoon affair, but it could be at this rate. Oil samples is a moot subject. We'll get to it. As I said, it's the thing is with an oil sample is it's a snapshot in time. Okay, so an oil sample can tell you an awful lot, and we'll see some oil samples in a minute or in time, and you can see exactly what the oil sample is telling you. But unless you've got history, an oil sample is how things are right now. It doesn't tell you whether things are getting progressively worse. It doesn't tell you whether things are stable unless you've got history. If you've got previous oil sample results, then you can see that there's a deterioration in the engine or not. So when you take one, basically it's a snapshot in time. So, and well, I don't want to spoil what we're going to get to. So we'll leave that one in abeyance for a minute. But yes, I mean, I do take oil samples, and I took an oil sample on a boat, an azimuth in Portugal only last week. A set of oil samples, and a couple of those results are going to be on the slides in a minute. The issue with taking oil samples is turnaround at the lab. Interesting to see James Wren can get it within 24 hours. I wish I could. Even in the UK, because my lab is based in the UK that I use, it would take me about 4 days, normally 4 to 5 days, to get a turnaround on a set of oil samples, which might not fit the program for the purchase of the boat. But it could still go ahead, and then the oil sample at least is there for future reference. And then my recommendation is that you then take another oil sample later on and continue the process on an annual basis. When you do an oil change, take an oil sample, and then you can at least monitor the condition of your engine rather than just know what it's like at that particular moment in time. Does that cover it?
Perfect, Geoff. Perfect.
Okay. So we get to the cooling system. So we've got some water out now. Sometimes it's as clear as a bell. So there's no inhibitor in there, no antifreeze in there. And you can comment on that. Sometimes it's absolutely disgustingly muddy brown water. Very often one engine will be cleaner than the other because one engine will be connected to the calorifier. And the engine to the calorifier, normally the cooling water is not as good as the engine that's not connected to the calorifier because for obvious reasons. So that's another thing. That's an interesting point as well, because then you can make a note of that and you can say, well, I know that the starboard engine is connected to the calorifier because later on when you get to sea trial the engines, that will have an effect. And you need to know what that effect is. And then you can say, when everyone's starting to twitch and say, oh, that engine's getting much hotter than that one, and then you can explain why, because one of them is connected to the calorifier. Okay. Exhaust systems are probably the most important part of this process, and we will see why later on. But you need to check the water system, water injection manifolds. Now, a lot's been said, and there is a surveyor out there I know, and he says that if your water injection manifold is an iron manifold and it's more than 5 years old, scrap it. Well, that's all very well, but it does annoy brokers when surveyors make bold statements like that. There's no guarantee that the manifold is completely wasted away just because it's 5 years old. However, there are circumstances which could lead to that, and that is more important to identify, especially on stern drive installations, which we will come on to later on. But even on any boat, the exhaust system and the height of the exhaust system in relation to the waterline is the single most important thing. Now, I had a report sent to me this morning from a surveyor member, and he mentioned in his report that the water injection manifold ideally should be on a vertical piece of pipework, and because the pipework is at 45 degrees, he didn't consider that was ideal. Now, I don't know where he got that idea from, because I had an occasion where I pulled up the fact that I thought that a water injection manifold was too shallow on a boat, and I got a retort back from the manufacturer to say, providing it's greater than 6 degrees, it's okay. Well, I think that's cutting it a bit fine. But I did have an occasion some years ago, a gentleman who I'd done a previous survey for, and he bought, and I don't mind mentioning the boat because it's out there anyway, it was a Sea Line T60. And because he bought it in Scotland and it was only 9 months old, he said, well, Geoff, he said, I'm not going to drag you all the way up to Glasgow to have a look at this boat. He said, it's only 9 months old, I'm sure it'll be fine. So I said, well, that's entirely up to you. When you get it back down here, if you have any problems, give me a shout. Sure enough, a couple of weeks later, I get a phone call, Geoff, I think you need to come and have a look at my boat. He said, I've already called the local Volvo guy, and he said, when he went into my engine room, he started laughing. And he said, no, I don't think it's very funny, really. He says that it's not been built properly. So I went down to have a look at the boat, dropped down into the engine room, had a look at his port engine, and there was the water injection manifold on top of the turbo, running horizontally towards the outside of the boat. So I said, well, I can see why he was laughing. I said, but it's not really very funny. So basically, you were injecting water straight into your turbo. The boat didn't make it as far as Itchin Bridge. It only started off at Shamrock Quay, so only got about half a mile before the turbo seized up. Needless to say, this was, being a brand new boat, you'd have thought that they'd have built it properly, but you know, you can't guarantee these things. These things happen. Unfortunately, this was boat number 2. So I knew that there was another one out there, and I wrote an article and put it in the report magazine saying this is what I found, because there were other issues with this boat on air and combustion air, because every carpet in the boat, which was lovely and white, but every white carpet in the boat had a black line around it where there was a bilge trap, because the engines were busy sucking air from the bilge because they couldn't get enough air in through the air intakes. So there were several things wrong with this boat, and it was inherent with the design. And we got a member in, it was in the south of France, I believe. He was certainly in the Mediterranean. And he wrote to me an email a couple of weeks later saying, I've got boat number 1. And it was built exactly the same. So, and it had had a turbo failure. So, yeah, exhausts are important on new boats and old boats. It's always important to make sure that the exhaust is properly designed and properly put together with proper hose clamps, proper exhaust hose clamps, not just Jubilee clips, and that everything is secure and not leaking either. So on the subject of leaking, check for leaks. Right, so check the boat for leaks, the engine for leaks, oil leaks, water leaks, corrosion. It gives you a bit of a. We'll see some evidence of leaks later on coolers and things, and sumps on petrol engines. A lot of petrol engines, American V8 petrol engines, especially on stern drives, were marinated, um, uh, commercial vehicle engines, which had steel sumps. And steel sumps don't like bilge water. And when they get wet, they rot. And rotten sumps is a bit of an issue. One of my historic craft, which was being very carefully put back together, they made a decision not to take the Foden engine out, but they would rebuild it in situ because it was perfectly fine and everything else, da-da-da. And they finished refurbishing the boat, which took a considerable amount of time. And then they decided to take it out for a run. And then halfway through the sea trial, the sump fell out of the engine because it was like tissue paper. And an instantaneous lock of the lube oil didn't do the Foden any good at all. And that was the end of the engine, night sooty. So if you can't see the sump, this is where your handy camera on the end of your arm comes in. Get down under there and take a photograph of the sump because engines that have rotten sumps don't last very long. So while you're checking for leaks and everything else, also need to check for evidence of maintenance. Are there any clean bits? So you've got a nice bright green engine with grey turbos. Oh, so we've had replacement turbos already. Why have you had replacement turbos? Then it starts the thought process. Why have the turbos been replaced? Is it because of airflow? Is it because of overheating? Is it because of back flooding? So you're just observing the scene of the crime, really. Any new bits on the engine? Are the fuel pumps new? Have they been replaced and they're no longer painted the same colour as the engine? Are there spanner marks on it? So are there lots of marks on the injector pipes? Have they been undone? You know, where has the maintenance been done? If you have a look on the coolers, on the end covers of the coolers, there are anodes there. Have the anodes been replaced? You can see because there'll be thread tape wrapped around a new one. Nice, bright, shiny anode has been screwed in there with thread tape. Or is it still painted green, the same as the cooler, never been changed in its life? Things like that. Oil filters. Does the oil filter look like it's been recently changed? Had an issue on a boat earlier this year where I was a generator engine, and when I took the acoustic covers off and did my inspection of the generator engine, there written on the end of the oil filter was 0715. So they're right. Well, obviously the oil filter was last changed in July of 2015. When I asked for the service history, oh no, the engines were all fully serviced and the generator were all done a few months ago. But no, they weren't. Yes, they were. Yeah. We've got invoice history and everything. It's all been done, and it hadn't been done. It was just that somebody was charging for service in the engine and wasn't actually doing it. So it didn't stop at the generator oil filter, I can tell you. It went a lot further than that. Anyway, check the bearers and the mountings. All right, bearers and mountings, we'll see a little bit. This is a bit of a problem because it's very difficult to assess the condition of a mounting. I know that there are engineers who use a crowbar to actually try and lift the mounting to see whether the rubber is still connected. A little bit, all right on a small engine, you have a bit of a job on a big engine, but also a little bit questionable because you could actually be damaging it yourself. If it looks like it's settled, if it looks like the metal cover over the rubber is actually coming down and actually getting close to the base plate itself, then it's a good indication that the mounting rubber itself has settled over the years and that the engine is slowly working its way downward, which it will, and which will happen. But then again, the paintwork gives you a clue, have the mountings been replaced, or are they the original 20-year-old mountings, in which case they will definitely have settled. And that alters the engine alignment and can affect other things. So then you need to make recommendations in that regard. course, the most common thing you're going to see is that the engine mounting underneath the seawater pump is the one that's suffering from corrosion because of all the leaks from the seawater pump over the years, which have dripped over the mounting. So I've got another case, another story here of a survey that I did on a little motorboat which had a single engine installation on a V drive. And when I went to have a look at the boat, because it had been, the guy had bought it, to be fair, a surveyor had surveyed it. On the basis of the survey, he bought the boat, took it out on a sea trial, and the whole boat was vibrating so badly. Him and unfortunately his dog that he took with him weren't very happy at all. Returned to the dock and shouted for help. So I go down there to have a look at it. Straight away I can see that the rudder's not straight. The shaft wasn't turning true. So we had a bent shaft, we had a bent rudder, having just passed survey, by the way. And then when I got inside, I found that the gearbox had a massive aluminium bracket bolted to it, securing it to the boat. So instead of having 4 mounts, the engine and gearbox now had 6 mounts. And I'm thinking, well, why have you got 6 mounts on it? Something not right here. I couldn't get to the stern gland because on a V drive, the stern gland was underneath the engine. So I got my camera in there, took a photograph of that, well, or what remained of the stern gland, because you couldn't get at it to maintain it without removing the engine, which hadn't been done. Turned out that the engine had the wrong gearbox, hence the mountings had been beefed up. The alignment problems were due to the fact that the boat had suffered a serious grounding incident 6 months prior to purchase, and the surveyor that did the survey obviously got an awful lot of work out of that particular brokerage and didn't want to upset anybody, so he said everything was fine. So mountings are important, really. You don't want to see additional mountings having been fitted to something just to try and stiffen it up, because that will point you in the direction of something else being wrong. I'm going to have to start moving on at this rate, aren't I? Right, checking alternators and ancillary drive belts. If you can get to them, make sure they're okay. Another problem with ancillary drive belts is that pulley wheels get corroded when boats lie unused for a long period of time, and then that corrosion, once you start using the boat, shreds the drive belt. Have a look and see how much rubber material is actually lying around. So you'll find on the inside of the guards, on the face of the engine, there'll be lots of little black sooty bits of rubber lying on there, and that's an indication that you've got wear on the drive belts, and there obviously is going to be a reason for that. Okay, getting on. Where have we got to? So we're working our way through that. Equipment, well, that's fairly self-explanatory, really. Equipment that you're going to need to do your mechanical survey. A hand tachometer is probably one that not all of you use. I don't know how many of you use hand tachos. A hand tacho is the only way that you're going to determine an accurate reading on the revs of an engine, unless it's got modern electronic control systems. The old tachometers on helm positions are notoriously inaccurate. And if you're trying to determine an engine's performance within 200 revs, which you should be, then the only way to do it is with a hand tachometer. Now, straight away, people are going to say, well, I'm not going to go jumping down into an engine room on a sea trial when we're bashing along in a 4.6 with a hand tachometer and try and find out how fast the engine's going. Well, you don't need to. The process that I use is that I actually put a reflective tape on the shaft, and I take the revolutions of the shaft, work it back through the gearbox ratio, and then that tells me how fast the engine is going. And that way you don't have to go into the engine room even. You can normally take your engine rev readings from the shaft, which could be outside of the engine room, hopefully, through a trap in the cockpit where you don't have to put yourself into any sense of danger. But the only reading you need to take really is the fly-up reading, i.e. is the engine actually achieving its revs when it's not attached to anything, when it's not in gear. And then the next time you need to check is whether it's achieving its maximum revs when you're going at flat sticks, because that's the important thing, as we will come on when we get to sea trials later on. So remote thermometer, you need a remote thermometer. A remote thermometer is a good thing to hang a thermometer in the engine room between the turbos if it's a twin engine installation, or just in the engine compartment if it's a single engine installation, to give you an idea of what the temperature of the engine compartment is getting to during the trial. Excuse me. The reason for that is turbo-driven engines don't like hot air. Right, so they wouldn't like it in here today, would they? No. Normally, aspirated engines can cope with quite a high temperature, but turbo engines don't like it because obviously they're sucking in hot air, compressing it, and making it even hotter. So by the time it gets into the combustion chamber, you've lost a massive amount of efficiency. Plus, you're overheating your turbo in the process, and we'll see a classic case of that later on. Your anti-freeze tester, well, we've already covered that, because you're taking a sample of the cooling water in the engine, and you're having a look to see how clean it is and whether it's at the right the right mixture. White filter paper for your oil test. Small camera, we've done. Headband torch. Now, this is something that I've taken on fairly recently, really, because now we've got LED torches. You can get these headband torches, which are LED, absolutely brilliant, and you charge them up on a mobile phone charger, and I find them completely invaluable because they leave you with both hands free, which is essential when you get to my age, because sometimes I can get into places and then I have a hell of a job getting back out again. So a couple of rags, because you're going to make a mess, especially if you're taking oil samples, which is the biggest problem with oil samples, which I'll come when I get to oil samples, is that in the process of taking an oil sample, you can't help it. When you take those plastic tubes out of the dipstick, or even if you're draining off an oil filter, it's very difficult to keep the oil where it should be. So you don't want to spoil somebody's nice, clean engine room, hopefully. So rags, very handy. And of course, some tools as well, because you might need to undo things as you go around. Did somebody want to come in and say something there?
Geoff, it's Mike, just popping in with a question.
Go on.
Andrew would like to know, what temperature do you consider is too hot for a turbo engine?
Well, there's no hard and fast rule to it, but 30 degrees in an engine room would be considered hot. Okay, but there you've got problems with ambient temperatures. So really, you don't want to be more than 10 to 20 degrees above ambient. Okay. Fans are of great assistance. You can have fans, supply fans and exhaust fans, or you can have one or the other. When we get to a case study coming up in a minute, exhaust fans, if you've got exhaust fans which take the hot air out of the engine room, which is great, you have to make sure you've got enough airflow to supply the exhaust fan and the engine, because you're now having two things that are now sucking air out of the compartment. On a large boat, a super yacht, something like that, then one clue is when you come to open the engine room door, is it sucked closed or is it blown open? And then you'll know whether or not you've got positive pressure in there or negative pressure in there. But obviously on small boats, you don't get that. And now you're down to the sooty carpet syndrome and all that sort of thing. But we'll have a look at that later on. But yeah, temperature, it shouldn't be too hot. I mean, you can't help it if you're in a hot climate. And that's why when we used to supply boats for Australia and for the Med, we used to make sure that the engines overperformed in the UK. So they would over rev, basically, because when they got out there, they wouldn't perform so well. Does that help?
Thanks, Geoff.
Okay. Right, we're moving on now to the gearbox. Again, gearbox manufacturer, type, Ratio, well, you need the ratio to go with your hand tacho for later on. Is it a flanged gearbox? Is it bolted to the engine, or is it separate from the engine? We touched on V drives. You could have cardan shafts in between, which is nice because then at least it kicks the gearbox away from the engine. It means that the gearbox can be rigidly mounted, which helps with shaft alignment and bearing wear and everything else. So that's all to the good. And it also very often means that the angle of the shaft brings the stern tube and the stern gland where it can be actually maintained. Mountings for the gearbox, again, I touched on that one a bit briefly there, where they put the extra mountings on the gearbox because it was the wrong gearbox. Gearboxes can be hydraulic or they can be manual, so you could have ATF, automatic transmission fluid, in there. So the fluid could be red, which is ATF, or it could be oil, and we'll touch on gearbox oil in a minute. A very emotive subject at the moment, and one that's come to light several times recently with me. So we're moving on quite quickly now because I don't want to keep you guys here all day. Conventional shaft drive and V drive, well, we all know what the differences are there. That has its own connotations because a lot of boats were changed from shaft drive to V drive in order to increase the accommodation space. So lots of different manufacturers, Sunseek, Nimbus, lots of different manufacturers have done it over the years. Princess haven't, I must admit, but they in order to put a midships cabin in, they need to get the engine out of the way. So to get the engine out of the way, you put a V drive in, and then the engine could be stuck right at the back of the boat. Drive through a V drive, maximises the accommodation. Bob's your uncle, off you go. Of course, what they don't do is they don't change the mouldings. So we've got a perfectly good moulding there. They cost an absolute fortune. So I'm not going to change the moulding. I'm just going to shift the engine, put a cabin in there, everything will be fine. Well, no, it doesn't. Because now the engine, all the weight is now right back at the transom. And now the boat's sitting too low in the water at the stern. So then they have to start messing with the boat to try and give it some lift at the back end. And I've seen some horrendous bodges going on at the factory while they're trying to solve this problem of plastering filler on the hull and then glassing it over in order to try and give some lift, putting like tunnels and scoops and skirts on the back to try and lift the back end of the boat. You even end up with barn doors for trim tabs just to try and get the back end up to get her up onto the plane because all the weight's now shifted aft. And then, as we'll see later on as well, this can affect the propeller because now the propeller's too close to the hull, because now you've actually plastered in this, you've got a propeller in now effectively in a tunnel, and that tunnel is shaped to actually make the propeller, the thrust from the propeller give lift to the back of the boat. You're now worried about your tip clearances between your propeller and the hull. And then knock-on effect from that is, I know on one particular model of Nimbus, is that the shaft then projects too far out of the P bracket. So then you get a very knowledgeable engineer come back to me a year later and say, well, my engineers noted that there's too much projection from the propeller poking out the P bracket. I said, yes, that's because the engine's been shifted aft and balance has been changed, and now, well, they've moved the position of the propeller is too close to the hull. So to get it further away from the hull, they projected it further away from the P bracket. And so it's a whole knock-on effect. So then you have to make a compromise then. Is it too far from the P bracket? Should they have moved the P bracket? Should it have a bigger P bracket? Should the shaft alignment? So, you know, they've made a judgment on it. You have to make a judgment on it. Is it okay or is it not? You know? It's a case of really knowing what you're looking at and going through the thought process of how you got to where you are. And certainly with V drives, always start thinking that the boat might have started as something else. Sail drives. Well, we're going to go on to a lovely sail drive in a few minutes. You're going to love that one. Sail drives are a really good idea. It means that you don't have problems with shafting, you don't have extra holes in the boat. But they bring with them their own issues, as we know that the the collars, the inflatable collars, can rot and they need changing at regular intervals. The sail drives themselves are prone to corrosion. If they don't keep the anodes up, it's plink, plink, fizz. Next time you pull the boat out, there's nothing left. So, and also a lot of sail drives have a seed cock built into them, which owners are normally not aware of because the cooling water is coming in through the drive and they're normally seized. And so sail drives have their own problem. Stern drives, well, we'll get onto that. Lots and lots of problems with stern drives. Nothing wrong with stern drives in the theory. I understand, you know, that the benefits of stern drives and everything else, but they do bring with them a wealth of problems. Steerable propulsion pod, I must admit, I haven't done a Yanmar one, but I've certainly done some IPS drives. And although I shouldn't criticise perhaps, but I've never found an IPS drive that didn't have water in it. They all seem to get water in the oil. So every time I do an IPS drive, I always insist on an oil test on the drive itself, which isn't easy to get to, but it really is. On some of the propulsion systems, you have to actually take the sample from the drive itself, which is not a bad idea because all the water falls to the bottom. Because when you're trying to get it out the dipstick hole, you probably get oil from the top and you miss all the water in the bottom anyway. ZF pod systems. Well, I mean, all this modern integrated drive system is coming with it, brings with it its own. I'm twitching here. With the electronic control systems on boats now, you've now got joystick controls, so you can actually move the boat in any direction you like by moving the joystick, as opposed to using throttles or steering wheels or anything annoying like that. And on the older systems, joystick control would be linked to stern thruster, bow thruster, and port and starboard engine. And so lots of things would be going on when you move the joystick in a particular direction. One engine would be going ahead, one would be going astern, one thruster would be going one way, one thruster would be going the other way. It was all quite intense and all prone to all sorts of problems. But of course now with the IPS systems, you can just literally steer your boat in any direction you like. Okay, moving swiftly on. So we're getting to damage inspections now. So those of you who do engine surveys or are engineers, I don't know how many engineers we've got out there, you will often get approached to do, as the gentleman did who supplied his inspections this morning, you get approached to do an insurance claim on a damaged engine, which is great stuff. I love these because it gives you time to put your Sherlock Holmes hat on and go down and look for evidence at the scene of the crime. So the process is to make sure you get statements, a bit like pre-purchase survey really, where you try and find out the service history, what maintenance has been done, what the history of the boat is, how many owners it's had, where it's been kept. You know, is it a boat that used to be in the Med that's now in the UK or the other way around? All this is all interesting information. Research. So then you have to go and again, same with the pre-purchase survey, same with the damage inspection, research what you're going to be going to look at, make sure that you know your ground, you know your engine, you know what you're going to expect to see. Your inspection itself, when you go to inspect the damage, make sure you're not distracted by anything and make sure you're getting to see everything you need to see. Very clever if you get somebody who thinks that they're in the frame here, so to speak. He's trying to cover something up, which we will see in a minute. That somebody did try to do, and it wasn't until I was on my way home in the car and I thought, no, I know what he's done. And I turned around and went back and we'll have a look at that one. And then analysing the results. This particular one, you're going to love this one. This was a sail drive failure. Okay, so as you can see, that's a picture of the sail drive with lots of bits of metal where the two bits, basically the sail drive and the engine fell apart. Okay, So the background to this was, in the history, that it was a recently replaced sail drive unit. Ooh. So the first thing is, this is new. This has been recently done. So as you can see, it's a nice shiny sail drive because it is absolutely brand new. In fact, it had only been on the boat for a couple of months. So first of all, I was a bit concerned because in all my experience in the past, when sail drives have rotted away, it's normally cheaper, and I know this might sound strange, it's cheaper to replace the engine and the sail drive as a unit than it is to replace the sail drive or the engine. And I questioned this with a major manufacturer, and they said that's because, it was Volvo, come on, let's be fair, and they said, well, that's because a unit I can give you a discount on because it's a whole engine and drive unit. A gearbox is a spare, so you don't get any discounts on a spare. So it actually turned out that the engine and gearbox together was cheaper than the gearbox on its own, than the sail drive on its own. So now I've seen this, I'm thinking, well, why didn't the repairer say, well, there's no point in doing this. I can give you a brand new engine and a brand new sail drive for the cost of the new sail drive. But instead, he's gone to all the hassle of fitting the old engine to the new sail drive and all the rest of this stuff. And I'm thinking, well, that really doesn't add up. So possibly he didn't get the discount. I don't know. But you've got to take it at face value. So that's the first thing that concerned me. Then we went and had a look and we found out that, as you can see from this drawing, there was a bolt there. I hope you can see the little pointer. That was the bolts that we used to hold the two together. Okay, this bolt here at the bottom is the bolt that should have been used to hold the two together. I think you can quite clearly see where the problem lay. Okay? So there was only about 3 threads on each bolt holding the whole unit together. The reason, and here is the bolts. The reason for that was, when I interviewed the guy, I said, well, for some reason you've used the wrong bolts to couple the two together. And he said, no, I used the bolts that were supplied with the kit. Well, actually, he didn't quite say that. He said, my subcontractor used the bolts that were supplied with the kit. So I said, well, your subcontractor used the mounting bolts to bolt the unit together, and he used the unit bolts to mount the unit. So he used the right bolts from the right kit in the wrong place. So there you go, human error. All right. Next one along here, and we probably see a theme. This is where we were talking about lube oil. This was a case where an engine, the background again, here we go, background recently rebuilt. Okay, so this was a recently rebuilt petrol inboard, a Mercruiser. So we can see a bit of a trend here. This thing, this engine lasted about an hour, start to finish. I think the actual engine itself only ran for about half of that time. So about 30 minutes running since rebuild. Statement from the owner was that when he tried to start the engine, it laboured a bit. When he finally got the engine going, it felt a bit tight. So interesting turn of phrase. Eventually the engine started overheating, smoke came out of the engine compartment, and the engine seized. So they managed to get the boat back to the yard. They took the boat apart, and the guy that rebuilt the engine said, the boat, it seized, the engine seized because of lack of cooling water. And the lack of cooling water was because the owner didn't allow me to replace the cooling water pump when I rebuilt the engine. So this is where we started. So then we went down to have a look and see exactly what had happened. Well, it wasn't lack of cooling water for sure, but there was certainly something going on with the bearings and the oil, because all the bearings had failed, and the worst bearings were those that were nearest the oil pump, and the best bearings were those that were furthest away. Now, Jeffrey can probably spot this himself, but if you notice on this bearing shell, there are locating lugs, little locating lugs. Well, when I first went to view this, I was shown a set of shells with all intact locating lugs, which meant to me that, well, they were all at least put in the right position. And then on the way home in the car, it dawned on me, I didn't see a full set of shells. So I went back and I said, where's the rest of the shells? The rest of the shells came out of a little bin at the back of the workshop. And when the shells came out, the locating lugs had been crushed because the bearing shells had been put in the wrong way round, which meant the bearing shells had then cramped onto the journals, which meant that the engine was basically stiff because the bearings were all squeezed together, and that's why they didn't last 5 minutes. And then the debris from there went straight through the oil pump and destroyed the bearings from the oil pump onwards. And so I advised the repairer, I said, the best thing you can do, sir, I said, is to completely rebuild this engine for this gentleman free of charge. So, another interesting one. But it was interesting that they kept all the damaged bearing shells or all the squashed bearing shells out of the way and only showed me the ones that were intact. So make sure you get all the evidence. Okay. So well, while we're telling stories, another one which came to light, which we come on to in controls really, is another case study here. Was a gentleman with a Fairline, nice boat, driving it from the flybridge, and an alarm went off to tell him that his engine was overheating. Whereupon he looked at his control panel, saw that the alarm was flashing on the port engine, and swiftly shut it down. And then decided to turn around and head back to the dock on the starboard engine. Unfortunately, the boat had had some recent work. Now we're really starting to see a theme here, aren't we? You know, so recently the boat had been rewired, and the flybridge, the alarms and the wiring for the flybridge were in reverse. So actually, when he shut down his overheating engine, he shut down the running engine and continued to run on the overheating engine, which expired quite rapidly. So, another one. So when you're doing your sea trials, always make sure that everything is as it should be. In trim tab controls are another classic on a sea trial. You know, down on one helm position, they work one way, and you get up on the other helm position, they work completely the other direction. So, okay. So, moving on, shafting systems. So here we are with our conventional shaft systems. Some of them have an angled gearbox, so the engine can sit quite level. Others have the engine angled, and engines are designed to run at certain angles, which shouldn't be exceeded. The engine details will tell you what the maximum down angle is. Down angle gearboxes obviously eliminate a lot of those issues. U drives and V drives. Again, the issue here is access to the stern gland, which is then underneath the engine. V drives are, well, some people say I just hate them. Me, well, we had a lot of V drives on our boats, on the landing craft especially. And to be honest, we suffered more V drive failures than anything else. They do tend to be very clunky, and they do have their own issues. Anyway, I'd better move on. Shafting materials. Most manufacturers these days use Temet, which is a trade name. Here's Temet 25 on the left. There's Aquamet, other design. These are tougher shafting materials than your standard stainless steel. Also, it makes them magnetic. So the first thing to do is, when you do your survey, I'm sure everyone does, get your magnet out, go around with your magnet, and that'll tell you whether you've got a Temet shaft or whether you've got a stainless steel shaft. Differences is between these, they suffer from different problems. Stainless steel is soft and wears. Temet suffers from crevice corrosion. If it's excluded from oxygen, corrosion can start, and you end up with like little wormholes in the shaft. Stainless steel shafts are soft and can be straightened. Temet shafts are hard and they can't. If you damage the Temet shaft, throw it away. I mean, a little sailing boat with a slight bend and a stainless steel shaft, we used to straighten them in the shipyard all the time, put them back in. Not normally too much of a problem. They can be trued up. Okay, there are shaft diameter calculations. This is getting into Geoffrey's realm now. Getting a bit technical, but all part of your research really is if you see a large engine and you have a small shaft and alarm bells are going off, then when you go back to the office, having taken the shaft diameters and the engine size, you can do some calculations just to make sure that the shaft diameter is appropriate for the engine installation. Bearing centers is another thing, whirling bearings. Right, the distance between bearings, you sometimes get intermediate bearing supports. You might get little brackets in between the P bracket and the shaft intermediate brackets. You might have actually bearings inside. You might have internal bearings because of the length of shaft. The issue there we'll get to when we do stern glands in a minute. I will cover a problem that we have there. So you could have on your shaft, you've got couplings next. So on flexible couplings, you've got R&D couplings. So on the right is an R&D coupling. On the left, you've got an aqua drive. The aqua drive comes with it, also takes the thrust. So it's actually bolted to a bearer inside the boat, which takes the thrust off the gearbox. Some gearboxes can have thrust bearings built into them and can take thrust. Some gearboxes can't and need a thrust bearing fitted externally. Most gearboxes these days actually take the thrust because it's too much grief and expense to fit an additional bearing. So connection of the engine to the anode. On a flexible coupling, we have a bonding strap. Okay, which because the engine is now separate from the shaft, in order to make sure that the bonded engine is actually coupled to the shaft, then you have to put an electrical bonding system, which is normally a wire. Some couplings have an internal system, so don't be too concerned if you don't see a bonding strap or a bonding wire, because some of them are actually bonded internally, and you can determine that by putting your continuity meter over the coupling, which I'm sure you all carry with you. All right, little story goes with this one now. Another story, just to bore you to tears. Interesting one though. It was an Aquastar which are built in Guernsey. Aquastar had been to a recent refit. Here we go, back on the theme again. So it had just come out of refit. The owner went, picked up his nice new boat to bring it back across the channel to the UK. So on his way up the Alderney race, his bilge alarm goes off. So he's got water coming in somehow. Lifts up the engine hatch, looks down below. Oh my God, the water's now halfway up the sump on the engine and rising rapidly. So we're going to take a detour and head for Cherbourg from the Alderney race. So he hangs a right and speeds up. Whereupon the amount of water in the bilge seems to be getting worse. So going ever and ever faster till he's flat out, he actually makes it into Cherbourg, radioed ahead. They had the crane ready and lifted the boat safely out of the water. Whereupon no water appeared to run out of the boat. So they pumped the boat out to try and find out what was wrong. And what it was when they'd overhauled the boat, they'd fitted a large braided metal bonding strap across the flexible coupling, and it was so long that when it was whipping around, it broke free, grabbed hold of the cooling water hose to the gearbox, sheared that off, and that's why the faster the engine went, the faster the water came into the boat. Nice one, that one. I must admit I enjoyed that one. Yeah. So here we go with here's a coupling on a coupling on a coupling. Nothing wrong with that, and at least it was bonded down. Not too much corrosion, but it would be nice to see all these being nicely greased up. And stern tubes and glands. Right, how are we doing for time? Not too bad. Okay. So top of the picture then, we've got a traditional stern tube on a rubber bellows, fair enough, but this is a 2-nut compression gland, good old reliable bit of kit, and it also has the benefit of offering some support to the shaft. In this case, probably not, because it's on a rubber tube, but if it's actually fixed to the boat, then it does offer some shaft support. If there isn't shaft support, then you've got a cutlass bearing in the stern tube itself, which is adding to the shaft support. And the reason for that, I will explain in a minute. Here is a couple of 2-nut compression glands. Obviously, we're running out of compression on this one, and we're starting to get some leakage. There's also surface corrosion on it, not particularly pretty. Both of those are in need of some overhauling. We've got one here. This is a lip seal gland. These Volvo manufacture them, and so do other people. There are other brands available, as they say. These glands need to be vented. I had a very experienced skipper last week in Portugal, and we did the out of water coding survey for him. When we put it in the water, I said, "Well, have you burped your gland?" Whereupon we all had a little laugh. And I said, "Yeah, I know, I always get a laugh out of that." Asking people if they burped their gland. I said, "Normally the guy on the hoist will ask you if you need to vent your gland." And he said, "Well, I've never done it before." I said, "Really?" So he said, "Yeah." I said, "Well, go down and vent it now." So he went down and he said, "No, I can't get anything out of it." So I went down and I showed him how to squeeze it, and he was amazed to hear all this air rushing out for quite a considerable amount of time before the water appeared. And I said, "That's why you need to do it, because I said, you need to have that water there to stop this gland from overheating. Although it's grease lubricated, it's also water cooled. And if you don't vent that gland, then your gland's running in air instead of in water, which doesn't do it any good." So even after all these years, you still find somebody who doesn't know these things. Now, you've also got mechanical seals like this one. Here's an interesting photograph, because this mechanical seal, and on there you can see my little sticky, which I used for my hand tacho when I did the sea trial, which stopped me from having to go in the engine room when the engine's screaming along. Okay, another water-cooled mechanical seal type gland. These will very often have a vent on them as well, which will allow the air to ventilate out, very often on a gooseneck, which goes high up in the engine room. Here's a squeezable gland that hadn't been looked after, hence all the water droplets. When we got to the sea trial, water was pouring out all over the place. So we won't go to that one yet. But on two occasions, I did sea trials on vessels, and I always go down and check the stern glands when we do a sea trial. When I dropped down, the shaft was whirling around like a Catherine wheel, and water was spraying out in a majestic fountain around the shaft. So I quickly told the guy to reduce revs, and as he reduced revs, so the whirring shaft calmed down and the Catherine wheel of water reduced. And I said to him, I said, "Well, when did you change your shaft seal last?" He said, "Well, I've just done it." He said it had one of those old stuffing boxes on there. He said, "I got rid of that and put one of these nice new mechanical seals on there." Unfortunately, the stuffing box was what was supporting his shaft. And when he changed to a mechanical seal, there was no longer a shaft support. So now his shaft was whirling around like a piece of string. So I had that on a sailing boat and a motorboat in quite quick succession, actually, which was quite interesting. And on both occasions, because they'd recently changed their shaft seal, but hadn't given any thought to the support that it was actually giving or not giving to the shaft itself. This one here, well, this is a really good example of why you need to have the camera on the end of your arm. This particular sailing vessel, I tried my hardest to get in behind the gearbox, to check the shaft seal, to check the gearbox, to check the coupling, and everything else that was going on in there, and there was no way in. There was a large removable panel with loads and loads of screws inside the lazarette on the port side, which I think could have been removed, or at least could have had an access in it, so you could get in there. You couldn't get in from either from the quarter berth on the other side. That was all panelled in as well. So in the end, I laid over the top of the engine, stretched out, and put my hand over the back and took a photograph, and this is what I saw. So I don't really know where to start here. Wiring, dreadful. The cooling pipes to the gearbox, awful. The shaft coupling, dreadful. You also notice down here, bottom left, there was actually a crack in the gearbox casing. There's an actual crack there. The stern gland, well, I still couldn't even see it. So I never really got to know what that was like. But dear me. My advice was that they had to create an access and maintain the area and strip all of that out and rewire it. There was a lot of advice went with that one. So there you go, a whole nightmare. But a good case for why you should have a camera, eh? Alignment, shaft alignment. Well, here we go back on shaft alignments. We can go to issues with settling engine mounts. I know on a landing craft that we had, which is a little case study. It was a brand new landing craft when we went to aluminium from wood in the 1980s, and we had this lovely brand new aluminium landing craft delivered, and rapidly the gearbox, the V-drive gearbox, developed a problem and failed. So my friend Kevin and I went down there to see what was going on, and decided we were going to take the gearbox out, strip it down, and find out what was going on. And when we disconnected the shaft from the gearbox, the shaft actually sprung up almost an inch. In fact, Kevin stood on it, and I couldn't get the bolts back in. We couldn't force it down that much. When they built the boat, they obviously had an alignment issue, and they must have almost jacked the shaft into position onto the gearbox. And there was so much pressure on the gearbox, it wrote the gearbox off. But that just goes to show, and that was a brand new boat, how ridiculous some people can be. Also on alignments, and I've had this argument with several manufacturers of motorboats, is that they do all their alignments in the factory and then launch the boat. And I said, yeah, well, now you're going to realign the shaft. No, we've already done that. I said, no, now you're going to realign the shaft. I said, because now it's a completely different scenario. Now the boat's supported in water than when it was in a cradle in a workshop. And I said, you're going to, but they don't. Notoriously, they don't. So shaft alignments will get done during the life of the boat. When you change the cutlass bearing and they pull the shaft, they will always have to check the alignment on completion. But shaft alignment is an important thing and can cause an awful lot of damage. All right, talking about damage. This was a shaft that might need realigning when it gets put back in. And it wasn't just the propeller either, because that was the rudders. There was a little grounding damage on a 75-foot fair line that sort of ran into some shallow water. Right, electronic control systems, EVC, EDC. So problems with electronic control systems. And one instantly springs to mind here. When you have a guy who's got a problem with a boat with an electronic control system. I haven't actually made any notes on this one, but I just thought about it, and it's really quite amusing. There's a gentleman who had an outboard motor on a very large outboard motor on the back of his rib, and he was a wakeboard fanatic. So to go with his lovely rib and his lovely outboard and everything else, he had an enormous stereo system which had two very, very large speakers clamped to the arch on the back of his rib. Anyway, he had this Mercury engine on the back, and it kept failing. It kept coming up with spurious, I'm running out of fuel, the lube oil's low, I'm not happy, and it would go into limpo mode. So he'd get out there in the bay, and then within a few minutes he'd have to limp home at a couple of hundred revs because his engine was dead. So after a while he got completely fed up with this, had the engine taken off the back of the boat, bought himself a Yanmar engine, fitted that, no problems at all, wants to sue Mercury basically. So we took the engine, put it on a test bed and ran it perfectly. Couldn't find anything wrong with it, plugged the engine history in, sure enough engine history was saying, yeah, this is wrong, that's wrong, everything's wrong, but we couldn't find anything wrong with the engine. So I phoned up the guy who was a friend of mine, who was the manager in the yacht club, and I said, what is it with this rib? Oh, he said, that bloody thing. He said, yeah, he said, they got these huge speakers on the back, play loud music, he said, drives everybody nuts. So I went back to Mercury and I said, what would be the effect of putting two very large magnets, one either side of your electronic engine? Oh, he said, I don't think the computer would like that at all. Fortunately, the Yanmar engine didn't have the same control system. Engine controls. Now, we're all going to laugh at this one. Going back a few years, when it was all by cable before before electronic controls, then you would have quite a complicated system if you had two helm control positions, because you've got one on the flybridge perhaps and one at the lower helm. And for that, you needed a system of connecting the two together so that you can use one or the other and never both. The issues here were that you needed starting gear protection. You don't want to be starting the engines up when your levers are in the wrong position. Biggest problem with there, and I actually came across this one. Fortunately, I wasn't responsible, but I was on the boat at the time, where the levers on the flybridge helm actually had a cover over it to protect it, and the flybridge cover meant that the levers had to be in a forward position in order for the cover to fit over the levers. But when you start the engine from down below, you're not aware of this. And if you haven't got a starting gear protection, sure enough, when the broker started the boat decided it was off. Unfortunately, we were still connected to the dock at the time. But I nearly fell off the back because it certainly did take off. So, yeah, starting gear protection and also changing from one controller to another and making sure that the controls work in both directions. Modern control systems have trolling devices, don't particularly like those, because basically on the clutched gearboxes, what the trolling device does is it slips the clutch in the gearbox, which isn't a good idea. Better really to run on one engine if you have to reduce your speed. On big motorboats, obviously it's a problem. You can't run on two engines at 4 knots because on a tick over in gear, you're probably already doing 6 knots. So you're on single engine. Nowadays, of course, you can have one control lever controls both engines. Everything's synchronized. So things have changed. Lubricating oil. Now we're getting on to the question that came up a little earlier in regard to lubricating oil. So we've covered pretty much what we can tell from from the oil on the gear stick, the dipstick, i.e. what the level is, what the condition of the oil, just an overall opinion of the condition of the oil. And you will find actually you can make a pretty good assessment of the condition of an oil just from what's on the dipstick. Another check is if you open up the rocket cover, if you've got froth in there. If it looks like the top of a pint of Guinness, then you've got water in the oil because then it evaporates out and causes the froth in the rocket cover. Taking an oil sample. Again, this came up a little earlier, and what can the sample show? Well, samples can be easy to take and they can be difficult to take. I did an oil sample test last week on an NTU engine boat. The port side was okay because the dipstick, because you don't get handed engines these days. So very often one dipstick is on the inside, the other dipstick is on the outside. The solution to this on this particular engine was to bring the dipstick tube over from the outside of the engine, over the top of the rocker cover, so that you could still take it, which meant you had a dipstick which was actually about 4 feet long. And to try and get your oil sampling tube down a 4 foot long dipstick tube, well, my oil sampling tube wasn't long enough. And eventually I had to take a sample off the oil filter. So I just had to undo the drain plug on the bottom of the oil filter and take a sample from there, which actually is a good place to take an oil sample from. Because to take it out of the dipstick tube, the engine has to be hot, the oil has to be hot, which makes it uncomfortable for you, because it has to have been circulated so that all the nasties in the oil are actually in the oil and not settling out in the bottom of the sump. So oil filter sample is probably a better way to do it, but in any event, it can be a messy process taking a sample. When you send the sample off to the laboratory, depending which laboratory you use, I use this particular one, they come back with a report, which you then have to do some diagnosis on, so that you can advise the client as what may or may not be wrong with his engine. This particular one came out satisfactory. As we can see here, no levels, viscosity is still good, no fuel dilution, there's no sodium in here. Sodium's really low, which would be, sodium is salt, which would come from salt water, which would indicate that there's a salt water leak on a cooler or something. Silicon is dirt. If you see a lot of silicon in there, it's just poor practice, really, is normally the cause of that. So really there's nothing too hazardous there. Next one. This one's got a bit worse. So we've now got a caution. On this one, we've got sodium. So here you go. We've now got an issue here, and he's probably mentioned it. Iron, so sodium, possible seawater. So I would suspect in this instance that this would be an engine oil cooler issue, where cooling water, seawater cooling, because the interface between seawater and oil in an engine will be in the cooler. It won't be, somebody said, oh, well, it could be a liner gone. I said, no, if it was a liner, it'd be fresh water. Okay, because it's salt water, it would have to be in the cooler. So this is a cooler issue. So his coolers will have to be taken apart and inspected. So it looks like he might be getting salt water into his. The iron levels, so there is a bit of iron level here, so there is some wear. Not massive, but what we need to determine there is how long was it since the oil was last changed? Because the next one you're going to love. All right, the next one is immediate action. Okay, this is massive, massive iron and lead. Okay, this is bearing wear on a serious scale. Okay, this actually is a gearbox oil, and although everyone was running around their headless chickens getting very upset about this, I said, well, hang on a minute, before you go too far, when was the gearbox oil last changed? The reason I said that is because I've had this so many times. This was only last week, this one, but I've had it so many times in the past where I've had a really bad oil sample from a gearbox. I've even taken magnetic, you do get magnetic drain plugs in the bottom of gearboxes. And we used to do our mag plugs on our engines in the service all the time, but it's something that people don't do, but they don't even know they're there half the time. But what I do is you have a drain plug in the bottom of the gearbox where you can drain the oil off, and very often that plug is fitted with a magnet, and that magnet is there to pick up all the iron in the oil. And when you take that drain plug out, it looks like a Christmas tree because it's just bristling with bits of iron. Now, you're going to expect a bit of this because when the gearbox is first fitted, within the first 100 hours of life, there's an awful lot of wear going on while everything beds in. Because you've got all those teeth meshing, you've got more mechanical contact in a gearbox than you have in an engine. So you're going to get a lot more debris in gearbox oil from the start. Unfortunately, gearbox oil, when you look at it, it's clean, isn't it? It doesn't get sooty. it doesn't get dirty. It's always clean. So when people check their gearbox oil, oh, it's clean and it's full. It's fine. So they don't bother doing anything about it. So very often, I mean, certainly the one before this, I said that a gentleman said, when was the last time you changed your gearbox oil? Bearing in mind this was a 20-year-old boat. And he said, well, I've never changed my gearbox oil. I've never needed to. So, well, that'll explain why you've got high metal content in your gearbox. Because he'd never changed his oil in 20 years. Again, service history here. But this is the problem with taking a one-shot oil sample, is because it is one shot. If he'd have had an oil sample 5 years ago, 2 years ago, 10 years ago, any previous oil sample, then we could have seen something. But seeing that, I just see a gearbox oil that's never been changed. Yeah. And it was a V drive to boot. Hopefully your laboratory, if you use them, will give you a breakdown of what the materials you would expect to see, just in case you're not aware of it. And what I normally do is I normally give the client a copy of this, so that, because obviously they won't know the technical detail of oil sampling and material content. Okay. All right, moving on, because I'm running over time here, Mike. Am I going to get shot?
No, we promised not to shoot you, Geoff. I don't know. I mean, I don't know how people are fixed for time. I would say aim for 2:15 latest. That's what, another 35 minutes, something like
Oh, don't give me a challenge.
that.
Okay, so cooling system, level, condition, the chlorifier effect, which we've already mentioned, the fact that the chlorifier water will obviously be grubbier than the clean water. Although, having said that, a boat earlier this year, where the service history of the engines was brought into question because of the oil filter on the generator and the general condition of the engine. Because when we did the sea trial, the engine temperatures continued to rise, which tells me that we had some fouling of the cooling system in some way. So either the cooling water pump impeller was worn, or there was some salt incrustation or whatever within the cooling system itself. So when I actually got to look at the engine, which unfortunately was post-trial at this stage, because we had to go straight out and do the trial, of course, I went down there and I squeezed one of the hoses. It was like squeezing a packet of crisps. It was like, because of all the amount of salt that was encrusted on the inside of the rubber pipes. So I said, well, you're going to have to disconnect all of this, and let's have a look at the end of the cooler on this very well maintained engine, which it wasn't. And of course, when they disconnected the pipework and looked in through the hole at the end of the cooler, there were the remains of the anodes trapped against the cooler tubes, and a great deal of salt incrustation, chlorification, debris, you name it, all blocking the coolers, because the engine hadn't been acid cleaned or maintained, and the anodes on the coolers hadn't been changed, and the whole service history was brought into disrepute, and the purchaser walked away, which was a shame, because it was a nice boat. It's just that there was too many things going on. So two different types of engine here. Obviously, there's a motorboat engine on the right, sailing boat engine on the left. Issues are the same: saltwater pump connections, salt on the flanges, evidence of corrosion around the saltwater pump. Here's a saltwater pump. Obviously, the cover. Again, here we're going back to the paint now. This cover obviously has been on and off a few times. Nobody's ever painted it, so that's why it doesn't look the same color as the rest of things. But also you can see that it has been leaking, and it was leaking at the time of survey, hence there is salt incrustation, and the mountings beneath were suffering from corrosion. Inlets. We're doing mechanical installations, engines and drives here, but it would be remiss of me not to talk about seawater inlets, as it's part of a mechanical installation anyway. And here's a seawater inlet. Okay, pipe works, double click, that's okay. The valve body itself, this is a cheap valve. It's not a good valve. I know that because I can identify it immediately. It's a basic hydraulic valve, which is a plumbing fitting, which are used by lots and lots of people and lots of manufacturers. You can see that the bonding cable is already suffering from corrosion. But the interesting thing here is, even though that's a cheap valve and it's probably made of the same material, there's a difference in the material quality, because this is a brass elbow and the brass elbow is on its way out. So even if that had been a bronze valve, if that's a brass elbow, then you got a problem. Okay, so that's new valve, new elbow, needs sorting out. Here, entirely different. Here you've got one which the photograph quite clearly shows has got CR written on it, corrosion resistant. So you might find DZR, designification resistance, and you've got CR, corrosion resistant. You've also got Tonval, which is brass. Very often there will be a stamp on the side which will identify it as being just brass. Unfortunately, it's not against the rules to fit these. So manufacturers will save cost. Rather than fit an expensive bronze valve to a boat, they'll fit a brass valve because it has to last 5 years. And by definition, a brass valve should last 5 years. But it doesn't really help the boat owner very much. But we know, I know certain manufacturers that if I go to look at a boat and it's over 5 years old, and I go down there and I can see that they're the original valves, then they need to be changed straight away because they're beyond their life. Even if they look okay, the issue there is I had one that certainly looked okay and the guy had looked after his valves and they still moved and they were clean. But when we came to work on the system and we shut the valve, it didn't actually close, because when we disconnected the pipework, the water came pouring in. And the reason for that, we found that although the handle was moving, the ball inside wasn't. So the valve remained open irrespective of the position of the handle, just because the valve had gone. So what you could see outside looked okay, but actually what was inside was completely shot. System-wise, here's a sailed boat system, which has been properly installed. All right. The only thing I would say is that his header tank's a bit low. I don't even see a level in that. But yeah, nice strainer, nice and visible. So it's easy to see that you've got cooling water flow, a nice siphon break on it, nicely done. All right. Evidence of past maintenance is obviously an important thing, but I think we pretty well touched on that one now. And modification states, even if you don't have an electronic engine, the engine number will give you the history of that engine, because every time a Volvo engineer carries out any modifications or any additions or alterations to the engine, that engine number is logged and the spares are logged against it. And so Volvo would know if the coolers have been changed, if the cooler modification has been carried out, if the water pump modification has been carried out. It'll all be in the history. Unfortunately, you need a Volvo engineer who has access to the Volvo system in order to determine that. Paintwork is a bit of a giveaway. Here's a turbo that's blistered the paint, but there again, you would expect that unless it's proper heat resisting paint. And here's an engine where the paint system has broken down a little bit, but not excessively so. Here's our old favourite, the D4 Volvo D4 end cap weeping issue. This is one that's caught out a lot of surveyors over the years. D4 Volvos had issues with their cooling water strainer, their seawater strainer, which was fitted after the seawater pump. Why Volvo fit the strainer after the pump instead of before the pump is beyond me, but they do, and that's the way it is. But it does mean that the strainer is subject to pump pressure. So rather than being on the suction side of the pump, where you're worried about air coming in, it's now on the pressure side of the pump, where you're worried about the water coming out, which on the early D4 engines, it did by the bucket load, because they had a plastic screwed cap on the strainer, which wouldn't stand the strain of the water pressure, and they very quickly all blew their end caps off, and their filter caps off, and overheated. And we had lots of disasters from overheating Volvo D4s, especially on stern drives, and we'll know why in a minute. The other issue then came to light was this end cap issue, where you've got salt incrustation there. This is because the end cap is actually leaking. Although it looks perfectly good, when the engine gets hot, the expansion rates between the end cap, the filler plate in between here, and the body of the cooler itself, they're three different materials, and they all expand and contract at different rates. And this meant that they used to bleed, but they would only bleed at full power. So when you go down, a very clever owner who's trying to sell his boat will go down there, wipe his coolers nice and clean, so it all looks good for you. You go out on the sea trial, and it all looks good. You come back from the sea trial, and you need to go back and recheck because you might see this. Right? That means that the modification needs to be carried out. I think by now most of them will have been done. Here's one who obviously has been done. You can still see where the engineers left signs of his gasket sealant. So this has had a new end plate, but lo and behold, there's still a problem going on. Okay, quite an expensive job with these, because getting to these coolers means quite a bit of stripping out, especially if they're on a stern drive. So it's thousands of pounds. Now, since this also has come to light that the inside of the coolers, the materials defects were not confined to the end caps and the end plates. Also, there is issues inside. These coolers on a Volvo advisory note are to be stripped and cleaned at a maximum of 5-year intervals. Right? Once they get beyond 5 years, the danger is that the cooler stack inside is corroding away. And I know a surveyor who eventually had to roll over and pay his excess because the owner of a boat said, "You didn't know that my cooler tube stack was corroding away." And he said, "Well, how could I possibly determine that without taking off the end cover?" And he said, "I don't care, you should have known." And his insurers, unfortunately, decided to have an out-of-court settlement, and it cost him his excess, which is grossly unfair. And the surveyor now won't have anything to do with D4s. He now gets them done by the Volvo agent, because he's not going to fall into that trap again. So other clues as to maintenance is condition of drip trays. You know, is there any oil underneath? Does it look? I mean, that looks like a nice installation. You know, it's clean. There's good access. It's got an airflow into it. It's a well thought out, well insulated. The only problem with that insulation is it hasn't got a white clean surface. Okay, shouldn't be like that now. Should be. It's always an advisory to have a white clean surface. These old insulation systems could soak up oil, and they did, and then they're no longer fire retardant. If you pull off a bit and you've got a match or a cigarette lighter, then you can always test it, but you'll find that, that they do tend to soak up oil. But that's another clue. Hoses. We touched on that briefly on squeezing cooling system hoses to check whether or not they are calcified on the inside. They should be pliable, they shouldn't be cracked, they shouldn't be crazed, and actually they shouldn't be painted. But unfortunately, manufacturers always paint the engine, and they never mask off the hoses. They always paint them as well, which doesn't do the hoses any good at all. there are standards for the hoses, so it's always worth checking. I mean, you certainly don't want a clear plastic hose on the hot side of the cooling system on an engine. Okay, it has to be a reinforced rubber hose on the hot side. You can have a plastic hose on the cold side, but not on the hot side. So their suitability. Fuel system, ISO 7840, A1. These are the standards you need for fuel system hoses, and you'll see a reason for that in a moment. Hydraulic hose you will see a lot of, because a lot of people use hydraulic hose because it's cheaper, more readily available, and so lots of people fit that. Lots of yards, engineers fit that, as opposed to proper fuel hose. Not a good idea, because it's not resistant to fuels, especially now that we have biofuel with methanol in. Those types of rubber are not resistant to it. And what happens then is that we have this. This was last week's boat. This is the MTU, the twin MTU installation, and these are the fuel hoses. One going to the starboard engine, one going to the port engine. You can see the breathers in the background. This one's the port one was cracked and crazed over the engine, which first drew my attention, and the starboard one was actually weeping. This boat we'd only just driven to be lifted out, so we'd actually been driving this boat only hours before, and it was scheduled to be used the next day, and I said no. Okay, the reason for that is this is the engine on the starboard side, and there is the fuel hose that was bleeding, running over the top of the engine, and you might notice that that is the exhaust system. And although it's lagged, I don't care, it's still hot. It's the hot end of the engine. Next photograph, this is the port engine. A much longer run of hose. This hose was completely crazed and cracked, and it's running over the top of a hot engine. It's a disaster waiting to happen. This is also the MTU engine with that wonderful dipstick, the longest dipstick in the world. Access on this particular installation, as you can see, is a bit limited. Although what you don't know is that inside the boat, in the galley, was a door which allowed you to come in at the other end of the engine room, because you could drop down through this hatch at the back end and see this half of the engine, but you had to go in through the galley to get to the other half. But those hoses were changed within hours of me doing the survey, and we didn't drive the boat until they were. So we saw that, and there's the oil filters, and that's where the hoses were running between the exhausts. So yeah, not the ideal. So now that brings us on to exhausts. Wet, dry, underwater, back pressure issues, flexible hose clamps and leaks. All good subjects here. Wet and dry exhausts. Most exhausts now are wet because it reduces the temperature of the exhaust, stops a lot of wild heat from entering into the vessel, means that they don't have to be isolated from the structure. So there's a lot of advantages to having a wet exhaust system, and you don't see a lot of dry exhaust systems, to be fair. Mostly on commercial craft, where they've got a funnel that looks pretty, they might have a dry exhaust system going up through the funnel, or they may have a dewatering system and still keep the funnel, which means that their exhaust system is basically dry and also water cooled. So they get the best both worlds. So underwater exhausts now are very common. The advantage with those is that they don't usually need to be drained. So when these boats are lifted and transported, the exhaust system self-drains. Unfortunately, that isn't the case with a lot of other systems where you've got water traps which retain water and keep the engines in a salty atmosphere, and also have problems when boats are transported and shipped, and we'll come to that one in a minute. back pressure issues, that's the issue with wet exhaust, is making sure that the back pressure is within manufacturer's recommendations. So very often the underwater exhaust will have a small opening above the waterline, which allows the back pressure to be regulated to within the manufacturer's recommendations. Hose clamps, we've already mentioned, proper hose clamps, not Jubilee clips, but proper clamps, and 2 of them on every connection. Dry exhaust systems can be large. Here's one here, been correctly designed, and of course in the lowest point of the system you still need to have a drain, a water trap. This can be left open. Nothing much will come out of there other than the water. Some of them are fitted with U-bends or water trap systems on larger vessels, but even a dry system needs some way of making sure that the water can't find its way back into the engine. Underwater systems such as this, so there we got a twin engine system where the exhaust is run outboard and then down through the bottom of the boat, exiting underwater. This one here is a dry system, and then having been well insulated and silenced, the exhaust is then run out to the side of the vessel, where then water is injected before it goes out over the side. This reduces the soot and makes it far more amenable on super yachts where you don't want nasty soot stains on their lovely boats. So designing water systems, this is from Halyard. Halyard are very good and very helpful, and I found them to be very helpful over the years with everything that they market. They put some good information out there, and I've used it in my module, and here is the same examples here. So they give examples of how you should design an exhaust system, mostly again to prevent back flooding. The extremes of wet exhausts. In this one, the issue here is to make sure that there is sufficient volume in the water trap to accept the water that may be in the lift. Because obviously that length of pipe will be full of water before the exhaust blows it away, and then it starts to fill up again. So the chances are when you stop, that water will then run back into there, and if this amount of water is greater than the volume in there, then basically it will also end up back in the engine. So I had a gentleman with a pair of Mercedes on an inland waterways craft who, and Mercedes had done a very, very clever system where the engine control system, on stopping the engine, there was a little valve which opened and drained the exhaust automatically on stopping the engine, which was very clever. Unfortunately, this valve had failed, and the guy had redesigned his exhaust without this facility. And he said to me, he said, I'm a bit concerned because the engine was a bit difficult to start. And I looked at it and I said, oh my God, I just realized what he'd done. What he'd done was, because they had this dewatering issue where the water level would run back into the engine, the valve was essential to get rid of that water. Without that, there wasn't sufficient volume to get rid of the water, and the water was actually going back to his engine. I said, you've been very fortunate up to now that you haven't obviously bent the con rods and had a compression issue. Fortunately, he got away with it because he'd only just done the work. So it was pretty close, really. But yeah, because he'd redesigned recent work again, redesigned his exhaust system, and he hadn't taken into consideration that they'd fitted that valve for a reason. Wet exhaust systems on sailing boats also have to take into consideration, obviously, the healing effects on the boat. So if you've got, if the exhaust system's not on the center line, then you can have the healing effect. If it's run to one side, then as the boat heals over, the water can run back into the engine. So again, this particular one had a before and after. In this actual instance, the water line was measured and marked, and it was found to be too close. So in the end, they raised it and put a proper siphon break in. dewatering silencers. Don't see them so much on main engines, mostly on generators. Very good. They're used on generators to make sure the exhaust system is silent, because the generator may be running overnight while people are sleeping, and they don't like the sound of water splashing. So they use a dewatering system where the water in the exhaust runs out through the bottom of the boat, and then the nice clean exhaust, which has been cleaned by the water, then exits through an above waterline pipe, and quite silently and cleanly. Water injection manifolds. This one is tangential. They vary depending on engine to engine. They could be in a cone. It could be water jacket type. This one here is the water is injected from the engine cooling supply here, and then it rotates tangentially around here, exiting through these machined holes inside, which then spray the water into the exhaust gas, cooling it and quietening it as you go. This one here, well, this was a sad tale, really. This was an insurance claim on a gentleman who had his boat returned from the Mediterranean, only to find that when he came to start his engine, it was full of water. Well, he couldn't start it. He got an engineer down. The engineer took the injectors out, turned the engine over, and salt water came pouring out of the injectors. So straight away, he put in a claim on his insurance. His insurers realised the boat had just been shipped back from the Mediterranean, so they claimed against the shipping agent. I got involved in the job to go down and find out what had gone wrong. Well, straight away, as soon as I heard about the case, I phoned up the shipping agent and found out who the loadmaster was, because I used to work with these guys. And I said to him, what were the circumstances when the boat arrived at the ship? And he said, well, they turned up. He said, tied it up alongside, and then they had to catch a flight. So they all jumped, legged it. He said, left us with the boat. So he said, well, no problem, really. You know, we managed all right. So I said, well, did you drain the exhaust when you lifted? Well, no, that's not my job. I'm not allowed to go into boats and start fiddling with people's exhausts. He said, this was down to the crew to do that. And he said, and they had gone. He said, so no, nobody drained the exhaust. So now I'm already starting to realise what's gone on. So I visited the boat here in the UK, went down. Why I went down, they didn't really understand, but I went down to have a look at these seized engines. But it wasn't to look at the seized engines, it was to have a look at his exhaust system, and that was the exhaust system. Warning, you must drain this exhaust before the vessel is craned, transported, or lifted. And it wasn't done. Needless to say, the insurers didn't pay up. So 2 engines completely written off. And it's all down to back flooding. Engine to waterline measurements then is a very important thing. So this is something that you must take when you do a mechanical installation. This is probably the most important part of a mechanical installation, because this determines whether it's a correct installation or not. Each manufacturer has his own measurements. This is Yanmar, who insist on a minimum of 250 millimeters. Volvo insist on 273 millimeters. But either way, outdrive, seawater systems. Now we get to the nitty gritty of having the measurements of the installation checked. Okay, so I'm not going to labour other points. I'm going to sort of concentrate upon this because this is the most important part of it. Outdrives themselves, as you know, they're fitted for convenience. So it means that you can fit the engine at the back of the boat. You can put it into a small space which maximises internal volume, and you can also fit it in underneath a fairly low deck. Unfortunately, it's the height of the deck which often creates the problem, because if the engine is fitted too low, then the solution is to fit a riser to the exhaust pipe. And the riser to the exhaust pipe needs clearance above the engine. So if the engine's too close to the deck, you can't fit the riser. So then they fit the engine without the riser, and now you've got a problem. And this is something I see a lot of, and have seen a lot of. And I hope I don't continue to see a lot of, because I hope people are getting better at it. But unfortunately, that doesn't seem to be the case. So even if it's a fairly new installation, don't take it as writ that it's right, because it could potentially have a problem. All right, so basically there's a unit. This is what you're fitting in a boat. This is how they're supplied. They're supplied in a box. So there's your engine and drive unit in a box. Stick it in your boat. But then you need to determine whereabouts is the exhaust. Here's your transom shield. As you can see, if the water level is above the transom shield, it's actually above the engine, which wouldn't be good, would it? Yeah. If the water level is at this level here, where you can see the top of the stern drive, then it's almost level with the crankshaft. So at least you know it's low enough. This particular picture is, it's a petrol engine installation. It's not the best one. We've got some better drawings coming up, but it does show something very clearly. And what that is that this pipe here, this downpipe, is common to all installations. And this will always be made out of the same material that the stern drive is made out of, aluminium. Right? This here is a manifold with a water injection point on it, will be made out of iron. Iron and aluminium in water, not good. The two are separated by a rubber bellows. So even if you get to this chappy here, which is a typical engine installation here, where you've got the same iron manifold, you've got an iron pipe, you've got a rubber bellows, you've got an aluminium tube, and then you've got an aluminium drive. So if the water line is where it should be, as is shown in this diagram, which is the installation instructions for how you should be fitting this engine. And now you can see that where the water line should be, and you can understand where the problems are. If that water line is a bit higher, it falls in the area of the rubber bellows. If the water line's in the rubber bellows and the engine overheats, that rubber bellows will melt, and then the boat will sink, because now you've got a big hole into the ocean. If the water line's above that rubber bellows, it's now in the aluminium. So now you've got aluminium and iron in the same piece of water. Won't work. You've got a massive corrosion issue. Same problem will happen. The connection with the bellows and the aluminium will fail and the boat will sink. That water level measurement is critical. Problem here is, and a point to notice is in the pre-inspection, where we mentioned earlier, when you look at the back of a boat, if you've got one stern drive installation, it's fitted at the bottom of the V of the hull, so that the cavitation plate here is in line with the bottom of the hull, where it needs to be. So that's a single engine. If you've got two engines, they're fitted higher up the V, still with the cavitation plate in line with the bottom of the hull. So twin engines will probably be fitted higher in relation to the water line than a single engine, unless you get the Sunseeker with the three engines, where you get two engines which are high up and one which is low down, and you'll find that they're all got the same exhaust elbows on, and it's the one in the middle that's going to fail. The other two will survive. Like saying, this is the measurement diagram for a Mercruiser. And again, you've got here maximum water level, clearly marked. On the old system, there would have been, if we can go back here, this is an old drive leg, not pre-duoprop. You've got a rubber buffer there. That rubber buffer is the water line. All right. On the old system, if the water line is above that rubber buffer, the engine has to have risers fitted. If it doesn't have risers fitted, you've got a problem. All right. The other problems with stern drives is you've got two bellows. You've got the exhaust bellows down here. the failure of the exhaust bellows isn't a big issue because that's blowing out underwater anyway, and water going back into the exhaust system is only going to go where it already is. This bellows up here is the transmission bellows. That is where the drive from the engine is going through into the gearbox. If that bellows goes, you've now got seawater going into your boat, certainly into your transmission, and there's no guarantee that's going to be watertight. So this is why inspection of the bellows and the service history of the engine, which should be serviced, and these should be changed every 2 years. Okay. Air intakes. Right, I might make it, Mike. I might.
I'm hanging on your every word, Geoff.
Okay, air intakes. All right, some more. We touched on this briefly earlier, that you have to have enough airflow through an engine compartment. So air intakes, you have topside engine slots. You know, this is a pet hate. I know that Jeffrey doesn't like topside engine slots, and neither does commercial coding. They don't like topside engine slots either, because they're below the weather deck. They're a down flooding issue, and you need to have some form of preventing the extinguishing within an engine compartment from exiting into atmosphere, which with a topside engine slot is a difficult thing to do. Fans, not so much of a problem even if you've got topside engine slots, providing you've got trunked supply to the engine, you can have fans fitted, and those fans can be fitted with louvers and they can be fitted with flaps, and that solves the firefighting issue. And it also means that you're less likely to get water coming into the engine room, because those trunkings would actually be looped up before they go down into the engine room, which stops water from just sluicing straight in. Unfortunately, not all manufacturers build them that way. So then you have to have spray eliminators, which normally you see spray eliminators where you've got an intake above the weather deck, hence the fire flaps and the filters. Here's one for your notebooks. This is a Sea-Line S330, which was a case study that I had, where we had a vessel that was 3 years old and had 3 sets of turbos fitted in 3 years. So quite a new boat. The gentleman had owned it from new. He wanted to sell it, but he wasn't happy. He said, I can't sell a boat that obviously has a problem. And although they, under warranty, they had replaced 3 sets of turbos, he said, that's all very good. He said, but there's something wrong. Well, Volvo engineers who had replaced the turbos free, good for them, they were a bit on the back foot over this. They wouldn't commit themselves. They just said that it was due to overheating. So, and he said, but I'm not happy. I think it's due to the airflow. So he called me in. So I went in, and this was the view from the engine compartment up to the engine intake. So that was the whole of the engine intake for this, one either side to be fair, but that's the whole of the engine intake for one engine. So the solution that Sea-Line had done, realizing that they had a problem, because they did realize, was to fit 6 louvered vents in the side of the moulding behind the sunbed. This is the engine hatch and sunbed, which closes down over it. So, well, they had the right idea. Unfortunately, when you close the sunbed, there's your louvered vents. So the sunbed effectively, well, it almost closed off the ventilation that they were trying to supply. And just to add insult to injury, the underside of the sunbed is fitted with 2 exhaust fans, which they had fitted to suck the hot air out of the engine room. So they're sucking all the hot air out, or well, to a percentage of it, and in the process starving the engines of air. So they'd fitted some louvered vents to try and improve the airflow, and then the sunbed effectively closed them off. the advice was to change the design of the craft and fit some proper vents that could work and supply a proper engine supply with proper fresh air. And this was what I would have liked to have seen. And that is what I like to see in a good engine installation. There's a turbo being fed with some nice fresh air trunked straight from atmosphere, which means it doesn't matter how hot that engine room gets, really, that engine's only going to be sucking fresh air. And God bless it, it'll be all the better for it.
Can I jump in, Geoff, with a question from Kim?
Yeah.
Is it really enough to fit automatic closures over the air fans on intake and removal side to satisfy coding?
Yeah. Is Kim a coding surveyor?
Kim is a coding surveyor.
All right, okay. Well, yeah, I should know the answer to the question then, really. Yeah, I mean, there are automatic fire flaps which operate with the fire system, fitted in a lot of fire systems. And they can be actual physical flaps on the ship side itself. And some of them can be manually operated, and some of them are actually automatic, which are operated at the same time that the fire system is operated. The fans themselves also can be fitted with automatic flaps. So when the fan stops, the flaps shut. And that in itself is effective and will pass coding. Stuffing rags in the slot is not acceptable as a means of retaining the extinguishing. The other way that you can not get around these things, but providing there is an automatic shutdown, even if there is a trunked supply that doesn't have a flap in it, providing that the extinguishants in a machinery space, if it's a gas, that the issue is that the gas can be lost to atmosphere and lose its effectiveness. If it's dry powder, then that doesn't happen. So you don't need to retain dry powder in the machinery space. Therefore, the problem goes away. The other way around it is to have over 100% capacity on the gas extinguisher, so that providing there is no forced ventilation, and there is a way of restricting the extinguishant from exiting the space, providing there is 100% over extinguishant, then that should be sufficient to overcome the issue. Does that make sense?
I'm sure Kim will let us know if there's a follow-up. But please keep going, Geoff.
Yeah, okay. Now, I'm going to clock back a little bit because when I was talking about these stern drive and water lines, I overlooked a very important thing. And because I was a bit mindful of the time, really. But you'll notice here, and it does mention it here, so I'll hark back to this, so it's not just me saying this. The addition of extra equipment, such as generator, trolling motors, supplementals, fuel water tankage, could cause additional loading to the boat, which could cause water to enter the exhaust, causing engine damage. And I had a case on a Fairline vessel in Poole, where when I did the inspection, this particular vessel, Fairline had built horns on the back of the boat. You'll be familiar with that. You'll have seen those. So either side of the transom were mouldings that give extra buoyancy to the transom area. So, which is good to see. But unfortunately, on this particular installation, it was pretty much at the limit of waterline level to engine installation, and it didn't have the risers fitted. But the two contributing factors that made the alarm bells go off was it had the generator option. So in the engine room, they'd additionally fitted a generator which has its start battery to counterbalance it. So you had that additional weight in the engine room. And also the boat had been fitted with a set of davits for a dinghy to be secured on the back of the boat, which would have given it even more weight. And as soon as I saw all of this, I said, well, no, this is not right. I got into deep water over this one. The agent who was selling the boat was a Fairline agent, and he went straight back to Fairline, and Fairline came back and said, all our Volvo installations are guaranteed by Volvo. And I said, well, I appreciate that Volvo will assess the initial installation of an engine in that particular model of boat, but what they don't take into account, but they do in their instructions, is that notice there is additional weight which can cause an issue to the standard installation, in which case you need to fit risers, which the manufacturer failed to do. So, and that was on another boat. The first case I came into contact with was in Brighton. Nice bunch of guys, came from London. They looked like the Craze twins, really, but they were lovely guys. And they used to like going out fishing. And they bought this boat, which had recently been brought back from the Gulf, and she had been re-engined. And when I went to see it with their dead engines, where she was on her mooring, where the lifeboat had brought her back to, I noticed that the water was lapping the bottom of the bathing platform, and you couldn't even see the stern drives. So when I asked them what happened, they went out fishing, and they were stood on the bathing platform, doing quite well, catching fish. And when they came to start the engine, it wouldn't go. And the lifeboat had to tow us in, because both engines were completely full of water, because they'd fitted larger engines than the boat was supposed to have. And then 3 burly lads stood on the bathing platform, did the rest. But when we think that this is on boats that have had additional equipment fitted, or whether it's boats that were in certain circumstances, I've had so many of these. I had a brand new boat, which was only a few months old, out of Lymington in the Solent, and they went, the first time he took his family out, because prior to that it would only been him and his wife, but then he took the kids out and the dog, and they went off down the Solent and anchored off Hurst Spit, and when they came to start the boat, it wouldn't go. They phoned Sea Start. Sea Start came and said, sorry mate, but your engine's full of water, towed them back to Lymington. So he contacted the broker. The broker said, well, there's nothing wrong with the boat. It's obviously you've done something wrong. So we got involved, and I went down there and had a look at the boat. And I said, well, the engine's hasn't got any risers fitted. It's fitted too low in the boat. Well, no, it didn't, said the representative from the manufacturer. And I said, well, yes, it is. So he said, well, we'll prove it then. So he disconnected the rubber bellows on the exhaust and said, there, you see, now water's coming in. So I went down and had a look at the plate on the boat, and the CE plate said that the boat was certificated for 6 people. So I said, right, can I have 6 people, please? Can you just climb on board that boat? And by the time the 4th person got on the boat, it started to sink. Because at the end of the day, it's in the loaded condition. Okay. So anyway, I think I laboured that point now, but I forgot about that, sorry. Insulation, we covered briefly insulation. Should have a white, clean silver finish, because that stops oil and oil mist from getting into the foam itself, which then becomes a future fire hazard. So it might be fireproof when you buy it, but 5 years down the line, it no longer is. Mountings and flexible feet, we did cover briefly. This one here on the left has got jacking bolts on it, which is great. For maintenance, that's very handy. This is a standard one that you'll see regularly on engine installations. Again, if that metal cap is actually down and almost resting on the base plate, then you can pretty well say that the rubber inside is over compressed. You can actually see the rubber on that one in particular there. Engine mounts, sometimes engines are changed. This particular boat has been re-engined. The engine's at a peculiar angle. I don't particularly like that, but they've actually manufactured a wedge so that they can fit this particular engine in and bolted it to the original structure. All right, we're going down to general notes now. So when you're assessing an engine compartment, the other things that you need to consider is the maintenance issues, layout of the engine room. Can you actually get to it? Can you actually get around the engine? I mean, I must admit, you know, even in my youth, I used to struggle around getting around the outside of some of these engines. Because they're not handed, you can often find that the starter motor on one engine is easy to get to. On the other engine, it's on the outboard side of the engine, you can't get to it. So handed engines were great in the old days, but you don't see it nowadays. But it's something to consider when you're thinking about maintenance issues. How can the engine be properly maintained if you can't get access to all parts of the engine? Generators, even worse. They're a brand new sailing boat from a very, very top manufacturer recently. I mean, this is like £2.5 million worth of sailing boat. And I went to check the generator out, and the generator is in the starboard cabin, behind the panelling, and behind the structure and the pillar that supports the cockpit. And actually, I couldn't even get the acoustic cover off the generator. And I said, well, how can you possibly maintain it without, and this main bearer wasn't bolted into place. It was part of the structure. You would have had to have cut the pillar away just to get the cover off the generator so you could get inside. They'd actually dropped it in through the deck. They dropped it in and built it into the boat, basically built it into the boat. It was just ridiculous, absolutely ridiculous. And this is a brand new boat. And how can you possibly maintain that? You know, without serious major surgery, you just can't do it. So another thing to take into account is what's also being driven by the engine. And I'm looking at the clock, Mike, don't worry. Is ancillary equipment. So, you know, hydraulic pumps, additional bilge pumps, and they're running off the engine as well. Have you got one drive in one direction and one drive in the other direction to balance it out? You know, PTOs, all things that need taken into account. Now we're getting down to the sea trial and engine performance. So we've looked at the engine, we've looked at how it's fitted and how it's installed. Hopefully we've found that there's nothing wrong with it. Now we've got to go out and give it a go. So start the engine up, make sure it's not smoking terribly badly. What's the tick over revs per minute? Is it in accordance with, there should be on a lot of engines, well, there will be in the spec what the tick over should be. What's its fly up rev? Out of gear, take the engine out of gear, take it to maximum revs. Doesn't work on a lot of electronic engines now, unfortunately, because the electronic controls won't allow the engine to over rev. So if the engine's not under load, it will be restricted on what it can rev to. In the old days, a cable-driven boat, then you could actually rev it up and see if it actually got to 2,400 revs or not, out of gear. If it didn't get to 2,400 revs out of gear, then it isn't going to get to 2,400 revs when it's in gear. So, okay. Does the smoke or any smoke clear when the engine gets warm? And then we have to do the performance on trial. Performance on trial, again, is if it's an electronic engine, you can trust the engine's instrumentation. Nowadays, engine monitoring systems come onto the big screen, the big computer screen, and you can see turbo pressures, you can see everything. Seawater temperature, inlet temperatures, every single aspect of the boat can be put on screen. Not so in the old days. You get a temperature gauge, you get a pressure gauge, and you get a tacho, and that'd be your lot. But so things have moved on. So you have to make the best of what you've got on the day. So for sea trials, you need to record the specifics of the trial, date of the trial, location of the trial, number of people on board is important for the loading, fuel tank contents, water tank contents, black water tank content, grey water tank contents on some boats, the condition of the vessel. Is it fully stored up? Is there loads and loads of owner's kit on board, or is it fairly light? Measure the waterline, because then you've got a known datum. So measure the waterline aft, port and starboard, and at the bow. And at least that way, if anything should happen in the future and the boat should be retrialed, you can say that it's not in the previous trial condition. Again, make sure all the controls work. And nowadays, we also take a note of the amount of noise in the accommodation, which I know on super yachts is a major issue. And we used to put masses of lead and all sorts of insulation devices between engine rooms and master cabins on super yachts, just to keep the noise levels to an acceptable level. Sea trials. Well, sometimes you can't do it because you're on a river. Another story coming up. And so you can only do low rest minute. But I always, and I'll show you a sea trial procedure in a minute, I always take a vessel from tick over to full power, depending on whether it's a new vessel or a second-hand vessel. The one I'm going to run through with you today is for a second-hand vessel. For a new vessel, we do it in greater increments. So we do like every 100 revs. On a second-hand vessel, I just do every 200 revs. Every 100 revs is too pedantic. And I don't do some things that I do on new vessels that I do on old vessel. But it's just because that's the way that the client has driven my sea trial procedures in the past. So again, you're checking revs per minute, water temperature, oil pressure, gearbox, oil and pressure, voltage. Are the alternators actually cutting in? Are they supplying power to the batteries? Speed in knots, if the log works, speed in GPS, speed over the ground, and observations such as turning circles and everything else. So sea trial observations there. Exhaust on acceleration. Normally when we do an acceleration trial, certainly on new vessels, and it's a case of from zero, put the levers 100% hammers down and see how quickly the engine picks up and gets to full power. And during that, depends how much smoke you get. On these clever engines nowadays, obviously you won't get very much on the old engines until the turbos cut in, or even the superchargers got up to speed. You would get quite a bit of black smoke to start with. Nowadays, it's almost eliminated by the computer. Crash stop from full speed. Now here's an emotive. So I've done crash stops from full speed on commercial vessels, on ferries and on ships. I don't actually agree with crash stops on pleasure vessels. Main reason is pleasure rated engines and pleasure rated gearboxes are not really man enough to cope with crash stops. There will be limits set by the manufacturer with the gearbox, and very often it is that the gearbox, you will have to return to neutral and pause for, well, we used to say 2 marching paces. So you'd pause for a couple of seconds and then put it astern. If you go straight from a head to astern, the chances are it'll all be flywheels and nuts and bolts. Astern operation, the reason for that is that if you've got transom mounted exhausts, you can have an issue with stern wake causing excessive back pressure and on extremes stalling an engine. But on another stern drive disaster, a gentleman in Plymouth went full astern to avoid a windsurfer who sailed across his bow, and because he went backwards into his own wake, he back flooded his own engine. Trailing shafts. If during the sea trial, which is a bit of a trick to remember, if during the sea trial you notice that there is some vibration, it depends whereabouts in the sea trial and what performance you're doing at the time and where the vibration occurs as to what it might be. If it's low in the revs, it could be one thing. If it's high in the rev range, it could be imbalance in the propeller. If it's in the midsection, it could be harmonics, which is where gearbox, propeller and everything else all starts rotating at a certain speed, and a certain vibration will kick off. If you've got serious vibration, then you could have a misalignment issue, or you could have a bent shaft issue. The trick to do there is to do trailing shafts. Trailing shafts means that the surveyor goes down between the gearboxes and puts his hand on the engine mount. What you do then is you shut down the engine that you're checking and you run on the other engine. The other engine is now trailing the dead engine shaft. If there is any misalignment issues or any bent shaft, the shaft will now drive the engine instead of the engine driving the shaft. What will happen is the engine will nod or it will rock, and that will tell you whether you've got a misalignment or a bent shaft. So that's why you trail shaft. It's to find a nodding and rocking engine, and that's how it's done. You let one engine drive the other, and it's the engine that's being driven by the shaft is the one that you check. Matching propellers, because there is a trailing gear in one gearbox, in order to achieve counter-rotating propellers, there is very often an idler gear in one gearbox to make one shaft rotate in a different direction from the other. This can cause a slight difference in speed of propellers in relation to engine. You can have a difference in speed. Mr. Broom was the only man I know, but he would actually alter the pitch of the propellers by ½ an inch on the port side in order to compensate for this. Nobody else ever bothered, and to be honest, I've never really thought that it's a problem. Engine compartment ventilation we've already done. Engine not achieving revs. This is the whole purpose of the sea trial, really, is to make sure that the engine is achieving its revs. An engine should achieve its revs if the boat is clean and the vessel is in a fairly light condition, then the engine should achieve its revs. It should achieve within 200 revs of its revs, the manufacturer will say. So it has to be within 200. But bear in mind, your maximum cruising speed on a pleasure-rated engine is 200 revs below maximum. So if you've already lost 200 revs, you're now operating that engine 400 revs below maximum. So really you're wasting power here. You're not getting the best out of your engine. So engine cooling water temperature differences, we mentioned earlier, if you've got a cooling system which is running on the calorifier, that engine will take longer to warm up. It will also take longer to cool down. So when you go on a sea trial and there is a difference in the temperatures of the engines, always bear in mind the calorifier effect. Engine high temperature, just had a little bit of an argument come back last week. A gentleman in Portugal who was selling his boat, the surveyor said that his engine temperature was too high on his particular engines. They were D6 575s. And he said they were running at 90 degrees, which means they're too high. Always check your ground before you make statements like that. If the gentleman had checked the engine specification, he would know that the engine thermostatic control doesn't operate until the engine gets to at least 87 degrees. That's before the engine starts moderating its own temperature. So the fact that it actually was at 90 was not actually a problem. That engine's quite happy to operate at 90. Another engine is probably happy to operate at 80. I'm not saying that. Always make sure you know what the operating parameters is of the engine that you're testing before you say that it's running too hot. Because some engines run at 90, some at 85, some at 80. You know, all engines are different. Modern engines tend to run hotter because hotter engines run more efficiently. And it's because of emissions. Hot engines, you get lower emissions than you do with cold engines. So part of trying to improve the environment and the lack of pollution is that engines are running hotter than they used to be. So it's always worth checking. Anyway, he lost the sale and he wasn't very happy with the surveyor. But there you go. Engine room temperature, we've already touched on that. Battery charging, always worth to check that. Oil pressure discrepancies, quite common on old engines. You can't always guarantee that the pressure sensors are going to operate exactly the same. So a little bit of difference in engine oil pressure doesn't necessarily mean that the engine is suffering. So here's a pre-purchase survey report cover sheet, which means you're making a note of the engine model, hull number, what day it is, who did it, engine manufacturer's model, rated horsepower, ratio, air temperature, it's important, water temperature, this is ambient air temperature, sea conditions on the day, wind speed, weather, tidal state, because you're going to do 2 runs, right? Unless you can go across the tide and you want to have a true idea of the performance, 1 run will be with the tide, 1 run will be against the tide, 1 negates the other. Trim tabs should always be in the fully up position so that you're not altering the performance figures. The effect of trim tabs is if you lower trim tabs at cruising speed, you increase the waterline length and you can actually increase the speed of the vessel by lowering the tabs a bit. Okay, on full power, leave them up. Where the test location is, how many people, these are your measurements, condition of the bottom, loadings, tanks, engine hours, equipment defects, and defects arising from trials. You might need a bigger column for some boats for the amount of defects arising from trials. During the trials, it's not just the engines you're trialing, you're also trialing the trim tabs, the steering, the thrusters, everything. And then the testing comes later. So then you're testing windlasses, winches, davits, passerelles, lighting, nav lights, radars. So everything gets tested within a sea trial. That's the time to do it. So this is where I would log the readings. Again, we go up in revs through the readings and we make a note of what they are. So as I just covered quite briefly, because I think we need to move on, is you're testing all the equipment on the boat, 12, 24 volt systems. If you've got a generator, do the 230. Obviously, you won't have an earth. When you test the electrical system, there won't be an earth because you won't get an earth on the generator. You probably won't even get an earth on the shore power either, depending on the marina. Water systems, which is important. Make sure that all the water systems work properly, all the lights work, all the instruments work, winches and windlasses, endless. It just goes on because some boats are fitted with so much equipment. And a lot of this equipment nowadays is so sophisticated, even I struggle with operating it. So I always insist I've got a skipper there who knows what he's doing so he can press the right buttons. All right. This one here, this is the ending of it all, really. This was my good friend, and I don't mind saying it's Chris Wilkes. Good old Chris. He sent me a photograph or a load of photographs last night. Geoff, I've got a good one for you. Might be handy for tomorrow. And he's quite right. This is actually a gear cable on a stern drive. Okay, that's actually a gear cable. It burst into flames. Now, we're all going to say, how can a gear cable burst into flames? Bearing in mind that this gear cable actually exits underwater, but it still burst into flames. And the answer was that the gentleman concerned had, undertaken some work recently. Now, where have we heard that before? And he'd fitted a new battery isolating switch. Unfortunately, he failed to mount it. So his loose battery isolation switch in his completely aluminium rib was resting against the vessel's structure. He actually turned his rib into a battery, which has done nothing for the aluminium, I can assure you. But this was the most interesting bit, because on trying to start the engine, the engine couldn't get enough current flow, so it was sucking the current through the gearbox cable from earth to give itself a decent earth, and that overheated the gear cable and it burst into flames. Because not only was the battery isolation switch touching the structure, but the earth connection on the battery wasn't properly connected. So yeah, he's lucky to still have a boat. And there you go. Any questions?
Geoff, thank you. Any questions indeed? Right, I have got a question here.
Good.
Richard would like to know, are you able to disclose the builder of the 2.5 meter sailing yacht with the built-in genset?
Oh, not there. Oh, the very expensive sailing yacht. Well, I was a bit disappointed, to be honest, because this particular manufacturer builds very, very good boats, and always has for donkey's years. And it's not unknown, because I wasn't the only one to say this. Somebody else has said to me, have you surveyed a new Swan recently? And I said, yes, I have. And they said, what did you think of it? And I said, well, I wasn't terribly impressed. And we got into a conversation, and it is something that hasn't gone unmissed. And there were other issues with the boat. But I mean, I think I would be treading on dangerous ground if I was to go much further. But it was a brand new 54-foot Nail-Auto Swan.
Okay, thanks, Geoff. And Kim's come back with a response. He wanted to say that coding surveyors don't know everything, exclamation mark.
Well, all the best ones do.
And he says the caveat about gas versus powder got him. Right, so Zenon's leaving now. Thank you very much, he says. Long day working. And so on. Thank you, Zenon. Lovely to see you online. So just before we close out, huge thanks to Geoff. I mean, that felt like a bit like a masterclass. And you certainly proved you know far more than I do about engines. So, but then that's not.
To be fair, Mike, you're not a surveyor.
I know. I have to cap.
You know a lot more than you think you know now.
I do. Yes, I do. So Ben wants to ask you, what are your thoughts about checking temperatures at the exhaust inspection point versus the ambient water temperature?
Yeah, I have. I don't know whether you have. Maybe I should have mentioned this on equipment bit. I've got one of those nice laser thermometers. I mean, it looks like a handgun, so you can point it at various parts of the engine and get a temperature reading. And yes, it's very handy to be able to point that at the water injection elbow and actually see what the temperature readings are, because especially on a twin engine installation, one might be at a slightly different temperature than the other, which can also point you in the direction of a problem.
Okay, thanks, Geoff. And if I could just do a little bit of unadulterated advertising, we do have some more reading material if any of you are interested in reading more. This is actually not written by Geoff. I think you did peer review it, and Jeffrey Casciani would have certainly peer reviewed it.
Yeah.
Written by,
it's Elliot, isn't it?
It's Elliot Berry, Small Craft Engine Survey. So that's available as a PDF, downloadable book, or as a paperback from the IMS website, should you so wish. Another question coming in here, I think. So this is from Andrew. What are your thoughts on the statements with regard to inspecting engines if there is litigation at the question asked, what's your qualification and is it current? I know you have a view on this, Geoff.
I'm sorry, I'm not with you.
Okay, so what are your thoughts on the statement in regard of inspecting engines if there is litigation,
right?
When the question that's asked is, what is your qualification and is it current?
Yeah, interesting, that one. because once qualified as an engineer, are you always qualified as an engineer? Again, this is where belonging to an institute can assist, because it's all down to, I had a conversation with somebody yesterday, and I believe I'm having a conversation with that person again tomorrow, it's down to professional CPD, really, continued professional development. So there's no, just because you're an engineer, perhaps you went and became running a vineyard for 20 years and never went near another engine again, then obviously your credibility as an engineer is going to be considerably less than somebody who has. So it's a case of continued professional development, keeping in touch, being a member of a professional organisation and being active in that organisation, and continuing to practice, I think, is the thing. That's where it all is. I mean, there's it's certain bits of knowledge stay with you for life. I had an issue, another story, we could go on here. I had a boat I did once. It was a broom, and nothing wrong with it. Everything was fine. 12 months later, I get a letter from the gentleman to say that my engineer was doing my cutlass bearings, and he said that my P-bracket securing bolts were corroded through. And I said, well, they weren't. And he said, well, he said they were. And it's going to cost me the best part of £1,000, over £500 just for the bolts. And I said, well, could you send me a photograph or a sample? And he actually sent me a sample of the bolt through the post. Now, during my training as an engineer, we did metallurgy, and mechanical failure was one of the subjects we had to do as an engineer. And I know the difference between a mechanical failure on a boat, crystallization of structures. Well, if you've read my module on steel and aluminium craft, you'll know where I'm coming from. And so it was quite obvious from my photograph that I took on the day of survey of these perfectly good bolts on the P-bracket, which had locking nuts on them, which meant that you'd have to undo the top nut before you could undo the bottom nut. And obviously nobody bothered. They just put a spanner on them and sheared the bolts off. And you could quite clearly see that the bolts had sheared, which I did point out to the gentleman that these are not corrosion marks. This is physical defect. This is shearing off. And so that little bit of metallurgy helped me a lot. And of course, the next phone call helped me even more, because I phoned the local propeller and P-bracket manufacturer, CJR, in Southampton, who were literally in the next yard to where the boat was. And I said, how much would a bolt cost? I'm being told that they're going to cost £60 a piece. And he said, you can have them for 59p if you like, Geoff, 75 pence if you want nuts and washers.
Yeah, well, there you go.
So, yeah, it's I think once an engineer, always an engineer, really. But I think that's the best I can say is it's continued professional development. Providing you stay as an engineer, keep working as an engineer, then I think you still have credibility as an engineer.
That's good advice, Geoff. I think just to pick up on the CPD points, if you are an IMS member watching this either live or on catch-up on video, then don't forget to claim your points for today. If you're not an IMS member, then, well, thank you for being with us anyway. So, Geoff, I think it's a good point to draw a line under proceedings. Thank you so much for sharing your incredible knowledge. Always good to spend time with you. I learn a lot. Kim's just told me he's learned a lot. So there you are. We always never know everything, do we? And that is the simple reality.
We learn every day.
We do. We do.
I've never had gear cables catching fire before, and I had one last night.
They are extraordinary. So good to see you, Geoff, and we'll see you soon. You've got to come and cut the ribbon on Murrell's house, which we now own in that wonderful turn of events. So the cable is ready here for, not the cable, lovely red ribbon and some gold scissors waiting for you.
I'm looking forward to that.
Good to see you all. Thank you, everybody. I'm going to shut things down now.
Thank you very much.
Great to see you. Thank you.